Hello, check. Honorable dignitaries, guests, speakers, ladies and gentlemen, a very warm good morning to one and all. I feel extremely privileged to welcome you all to the National Conference on Use of Smart Contract in Public Procurement and Supply Chain. So, for the opening ceremony, I would like to call Shri Prabhat R. Acharya, Director, AJNIFM, to please come and join the panel. Now I request Professor R.K. Shamsundar, Chief Guest and Keynote Speaker, to please join us. Dr. Madhuranjan Kumar, Head Procurement Research Center, please join us. Shri Sanjay Agarwal, Ministry of Finance. Shri Kavalpreet Singh, Ministry of Finance, so please join us. And our distinguished speakers, Dr. Amit Kumar Vishwakarma, Dr. Parvat Singh Anjana, Shri Deepak Lalan, and Dr. Sandeep Shukla. Now I request Shri Prabhat R. Acharya, Director, AJNIFM, to give the welcome address.
To you all distinguished guests, delegates, faculty members and staff from AJNIFM, members of the press. I welcome you all to this national conference on use of smart contract in public procurement and supply chain. It gives me great pleasure to welcome Professor R.K. Shamsundar, Professor of Eminence of IIT Bombay, who is the chief guest of this conference and will deliver his keynote address shortly. We're looking forward to his address, which I'm sure will set the tone for this conference deliberations. Besides, I'd also like to welcome Dr. Manoj Tiwari, Director NITI, he's not come yet, I think, Dr. Sandeep Shukla, Professor of Computer Science, IIT Kanpur, Dr. Parvat Singh Anjana, Postdoctoral Department of Computer Science, IIT Hyderabad, Mrs. Swati Bhide, she's I think joining a little later, partner IBM, and Deepak Jalan, Associate Director Accenture, who will deliver their talks during the course of this conference. I also welcome on board my colleagues, Mr. Sanjay Agarwal and Parvat Singh from the Public Procurement Division of Ministry of Finance. Now, as most of you would be new to this name called AJNIFM, I thought I must tell you briefly what exactly is this institute about before you proceed with the conference deliberations. Now, Arun Jaitley National Institute of Financial Management is an autonomous training institution of the Department of Expenditure, Ministry of Finance, Government of India. It has a unique mandate of meeting the capacity building requirements of the departments of central and state governments, including defense services, autonomous bodies, PSUs, through its various short-term executive and management development programs. Besides, it also offers degrees and diploma programs, which are a year to 2 years programs in the areas of financial management and financial markets. Besides, it is mandated to carry out various research programs and also various publications. The research programs are generally executed through memorandum of agreements or memorandum of understanding signed with client departments and are mostly action-based research as per the terms of reference given to us. These research outputs help the departments to take policy decisions. Today's conference emanates from one such research program that is being carried out by Agena FM through a memorandum of agreement signed with the Department of Expenditure, which has set up a procurement research center or a cell in Agena FM in January 22. I'd like to inform you that to this august audience that the Public Procurement Division of the Department of Expenditure is responsible for all policy matters relating to or pertaining to public procurement. Agena FM is the nodal center for public procurement capacity building programs on behalf of this Public Procurement Division of Department of Expenditure. Last year, Agena FM had organized an international conference on data analytics in public procurement and supply chain on 10th and 11th of June 22. And now, it's a matter of privilege for Agena FM that on behalf of the PPD of DOE, we are having the opportunity to disseminate initial fledgling steps that are being taken by Agena FM in this futuristic domain of smart contract to this August gathering of more than 120 delegates drawn from about 63 government departments, 29 PSUs, 25 academic institutions, and around 5 private sector organizations. I'm sure they will be joining us during the course of the day. So this gathering will capture by and large the entire geography of India, extending from Punjab to Meghalaya to Tamil Nadu. As some of you may be aware, Smart Contract is a self-executable computer program that automatically enforces the terms of an agreement between 2 or more parties. In the context of procurement and supply chain, a smart contract can automate many of the steps involved in procurement process, from initiating a purchase order to verifying the delivery of goods and services and making payments. Smart contracts can be used to ensure that all parties involved in the procurement transactions comply with the agreed terms and conditions, thereby reducing the risks of fraud and error in procurement process. Smart contracts can also help in improving efficiency in procurement by reducing the needs for intermediaries and manual processes. By automating many of the steps involved in procurement, smart contracts may also help to reduce the costs and improve the speed and accuracy of procurement transactions. Most importantly, smart contract facilitates transparency, traceability, and autonomy, both in design of contract as well as contract management. I understand that the autonomy and security in smart contract comes from the cryptographically secure capturing of contractually significant events. I understand that smart contracting emerged in the early 90s, but many issues and challenges remained. However, the emergence of blockchain technology has helped providing a platform on which smart contract could be built and delivered. Through challenges, those challenges still remain, particularly the initial costs, interoperability, legal issues, capacity constraints, etc. There are many potential benefits too. Smart contract is still an amorphous concept when it comes to public procurement. Therefore, this conference aims to enlighten the stakeholders and academicians interested in smart contract, public procurement professionals from government and PSUs, and private sector professionals interested in learning about smart contract in public procurement. The speakers who have kindly agreed to address this conference are the leading lights in the domain of smart contract in India. The Procurement Research Center of Agena FM is also attempting to develop the first ever smart contract for a Ministry of Government of India, and Dr. Amit Vishwakarma, our consultant on smart contract, will briefly discuss on that. We look forward to your active participation in this conference. And I think I will now leave it up to Professor Shyamasundar, Professor Eminence of IIT Bombay, to enlighten us with his inaugural address. Before that, I think the MC will introduce him. Thank you so much. Have a very good deliberations, please. All the best. Thanks.
Thank you so much, sir. So with this auspicious start, now I am going to start the inaugural session. So I will request all the dignitaries to please take the front row. Thank you so much. The inaugural address will be given by Professor R.K. Shamsundar. Professor Shamsundar is currently J.C. Bose National Fellow and a Distinguished Professor at the Department of Computer Science, IIT Bombay. Prior to this, he was a professor in Computer Science Department at Tata Institute of Fundamental Research. He is also an adjunct professor at National Institute of Industrial Engineering, Mumbai, a life fellow of Institute of Electrical and Electronic Engineers, and a distinguished alumnus of the Indian Institute of Science. He heads the Information Security Research and Development Center of the Department of Electronics and Information Technology of Government of India. He was awarded the 2014 SN Mitra Award for Excellence in Research by the Indian National Academy of Engineering. He has 8 patents, 8 books, and guided more than 40 PhD students. He has also been honored with a fellowship from British Blockchain Association. So I request Professor R.K. Shamsundar to please come onto the stage and deliver his lecture. So please.
Thank you. I think it's a pleasure to be here. First, let me thank Shri Madhuranjan Kumar for giving me the opportunity to address a faculty who are really interested in trying to see how contracts can be automated, or when you call a contract a smart contract, and when what would be the advantages or the disadvantages. And also I asked Shri Madhuranjan, what is the way, what is the audience? So he said there are lots of things, but you should speak as if it is a 101 course, and then I'm going to be addressing people who have questions or comments. You are free to stop me at any point. I think I will be giving for the next 1 hour and then 15 minutes as a question answer. So thank you again, all the distinguished speakers, and also Dr. Acharya, who is the director of the institute, who has also come to see how the conference and then what will be the impact. Thank you. So this is I think, this day of organization of my, there is, is there a way? No, I think either. Thank you. So it's the rough organization. So just to highlight the point, what is a contract and why do they go to smart contracts, and why do we call smart? Where is the smartness there? Because we are always confused with the smartness whenever we talk about something, including AI. So, AI of the Esther era, starting from Alan Turing and to what we call AI is totally different in some sense. So smart contract definitions, I'll just take a brief look and then give a brief on blockchain foundations, because that also will give you what are the issues for executing the smart contracts, and what is the scope of applications. And also I will try to highlight traditional contracts versus smart contracts, and what would be the issues or the conflict areas of smart contracts and the traditional contract. So, so this is something I thought it was good to see, because the smart contract idea was the innovation is all pervasive today. For example, even the policymakers foster innovation. Nowadays, the word innovation comes more from the policymakers rather than from the scientists or academic people. Like the European Commission declared we need to do much better at turning our research into new and better services and products if we are to remain competitive in the global marketplace and improve the quality of life in Europe. That's what with respect to Europe, and similar thing exists, like our Prime Minister goes on telling how innovation is important, kind of a thing. So innovation is seen as an economic driver and has led to political efforts to remove the rules and regulations that limit or restrain its development. The economic perspective of the role of innovation is economic growth is also embraced at a firm level. So now if you look at the original concept of innovation, it concerned novelties like imitation, invention, creative imagination, and social change. But now the current use is directed mainly at the technological innovation. And so the complexity of technological innovation poses a great challenge to the law. Disruption of the law is a phenomenon through which law becomes decrepit in the face of modernity. So now here, blockchain and its impact on economy, if you look, blockchain technically has sparked a revolution in several sectors of the economy, just as the internet did in an early time. However, the blockchain was developed, you should note, as the result of a venture that was driven by libertarian ideas, eliminating the need for intermediaries. That is the basic important things, such as central banks, courts, and other governmental bodies. Central to this revolution is the idea of contracting without the state. That is a major thing, and that's how people think transparency will come into the picture. By entering smart contracts based on blockchain technology. Of course, escape from the law is a mere illusion, as law will continue to play a vital role in private transactions. So now let us look at contracts. Contracting the world, now in an exciting period of innovation and research, contract law has proved to be sufficiently flexible and malleable in adapting to new technologies and transaction types. Of course, a top-down regulatory framework will always be needed, otherwise things won't work. Understanding and collaboration among scholars, practitioners from different jurisdictions, as well as among the legal and technical communities, approaching the intersection of law and technology. So now let us look at the origin of the smart contracts. It is technically, it was Nick Szabo in 1996. In fact, I think somebody asked him, are you Satoshi Nakamoto? Because he's such a very great innovator who has done a wonderful work. If you want to name two persons, one is Nick Szabo, another one is the David Shaw. Because these are two persons without which I think many of these things would not have existed, kind of a thing or the other. And so now here, if you look at what he defined, this smart contract, you see that it is 1996. Blockchain had not really come into the picture, or the Bitcoin had not. I should say Bitcoin, because blockchain is a byproduct of the Bitcoin kind of a thing or the other. And he said, the goal is to combine protocols with user interfaces to formalize and secure relationships over computer networks. Objectives and principles for the design of these systems, derived from legal principles, economic theory, and theories of reliable and secure protocols. See, you see how much technology that exists when you want to understand what is the notion of a smart contract. The blockchain is one such thing which gets embedded rather than that is not the only technology that is there. There are similarities between smart contracts and the traditional business procedures based on written contracts, controls, and static forms. So smart contracts, how did they arrive at it? Through the use of cryptographic and other security mechanisms, we can secure several algorithmically specifiable relationships from breach by principles. That means that using cryptography, just like what we say, it is immutability or whatever it is, that can be done through the cryptography. From eavesdropping or malicious interferences by third parties, up to considerations of time, user interface, and completeness of the algorithmic specification. So now, a classic example is a vending machine. A classic reactive systems, people who are in computer science, they know reactive and proactive systems. Reactive systems don't interact unless you hit it, it won't respond, whereas in a proactive, you go on doing it in a proactive fashion. For example, in this case, machine takes in coins via a simple mechanism, dispenses change of the product according to a displayed price, and a vending machine is technically a contract with the bearer. Anybody with coins can participate in an exchange with the vendor. The lockbox and other security mechanism protect the stored coins and contents from attackers sufficiently to allow profitable deployments of vending machines in a wide varieties of areas. This is a primitive ancestor of a smart contract. So there are other forerunners, as you can see, a point of scale, that is the terminals and the electronic data interchange and so on and so forth. SWIFT also is one of such things you can see. And these implement commercial security models, but too often with little heed paid to the contractual needs and obligations of the parties. And this is where the things comes into the picture. The smart contracts, though they go beyond vending machine in proposing to embed contracts in all sorts of property that is valuable and controlled by digital means. Smart contracts reference that property in a dynamic, often proactively enforced form, and provide much better observation and verification where proactive measures must fall short. See, that is the beauty of this. This is a classic example, a hypothetical digital security system for automobiles. Smart contract design strategy is successively refine the security protocols to more fully embed in a property of the contractual terms which deal with it. These protocols would give control of the cryptographic keys for operating the property to the person who rightfully owns that property based on the terms of the contract. And this is where you see how that happens. So now, what is the thing? Car can be rendered inoperable unless proper challenge response protocol is completed with its rightful owner preventing theft. And so if the car is being used to secure credit, strong security implemented in this traditional way would create a headache for the creditor. Repo man would no longer be able to confiscate a deadbeat's car. To overcome this, one can create a smart lien protocol like this. If the owner fails to make payments or installments, the smart contract invokes the lien protocol which returns control of the car keys to the bank. So protocol might be much cheaper and more effective than a repo man. And further reification would provably remove the lien when the loan has also been paid off. You don't have to go, as we have seen in many of the licensing or renewal licenses. As well as there are operational exceptions. As you can see, if the car is going at some 100 kilometers on a highway and it cannot stop, and now it is just the same strategy like what we have in our push-button cars. No, you can say the key is thrown away. Will it stop somewhere? No. Till you stop, it will continue to go. And when you stop, it won't start. So that is the way in which this has to be done in an automatic way. And this gives you a picture of how a smart contract is there, kind of a thing or the other. So smart contracts Of course, now one will say, what are the definitions? For example, even artificial intelligence people ask for a definition. So now, like Alan Turing, for whom we celebrated the century in 2012, somebody asked him, because he's the originator of the AI kind of a thing, he said, the day I'm going to define, it gets dead. So, so there is no single and universal definition of smart contracts, as has been observed. A search of the term smart contract uncovers a myriad of definitions. A consensus definition for smart contracts is yet to be reached, and a generally accepted definition of smart contracts does not exist. So I will take one definition and proceed with the underlying blockchain technology and come back to the other definitions later. Smart contracts and blockchains. Smart contracts are literally computer code that is placed on a blockchain, an open distributed ledger that runs on the computers of thousands of users, which has no central authority. So smart refers to the self-performing, self-enforcing quality of the smart contract, which I think I conveyed something through the automobile loans kind of a thing or the other. So these contracts are immutable, meaning that the code by default cannot be changed, that ensuring performance. However, for programmers, immutability presents a special challenge. Of course, you know, software bugs always continue to be there. Code contains bugs, coding errors, and code that cannot be altered needs to be written carefully, and these are all aspects you can look from different perspectives. So now let me just give a blockchain a gentle introduction. So now, as you can see here, here's the person wants to perform unless broadcaster willingness to transfer some money to Bob. And now the nodes check whether this thing can indeed be performed, and then if it is going to be performed, then it goes to the next one. And now here is a point there you have to understand is that now Alice wants to give 2 to Bob and somebody else want to give, and so these are all the transactions that have been collected, and now this has to be validated. That means that all the way from the genesis, is it possible this transaction will go through? I can account for each and every penny that is being there kind of a thing or the other, and now once that one is true, and then that becomes a block. And that block has to be added to the sequence of transactions or sequence of blocks of transactions that has happened to that, and then that is where this becomes the chain. So technically, this is a very gentle way to do that. You give it to all the stakeholders, and then at some point or the other, each one wants to add a set of valid transactions, and that valid transactions are going to be, somebody is going to be chosen in some manner or the other to say what is the block that has to be added to the chain, and then who would do that, you will come to that at a later point or the other, and now when that block, he is the winner, he will get it validated by all the stakeholders. So technically, it's a consensus, it's not even a majority, everyone says that this one is correct or there. So let us see what is a thing I can convey. One of them, let us say, Alice is Bob's grandmother and is passionate about technology. So she decides to code her last will in a smart contract. So in her will, she specifies that all her money that is in the form of cryptocurrency should be transferred to Bob's wallet address when she passes away. So additionally, she can specify further conditions, for instance, that the money can be transferred only after Bob's graduation. So now here comes the thing or the other, where one would say whether when do you certify the debt, when the graduation certificate is there, when the money has to be transferred, and where is the address to which the cryptocurrency has to be transferred. So this is technically a simple code that exists and that can run on the blockchain and then realize what that will is. There is no notion of a court or anything like that, and so this has to be executed. This is all completely automatic kind of a thing or the other. So now you have to observe something. This is also an important aspect. because blockchain is one in the cyberspace. And now you also have to relate it to the real world. And that is where you have to see where the things comes into the picture. And there also you will come to know what is the notion of a trust, etc., coming into the picture directly or indirectly. The smart contracts are essentially evolved wallet accounts characterized by a unique address and by a balance. That is the way the things are, because that is where the cryptocurrency is stored. It can store the state of some variables and their own code, which is on the blockchain. Alice could shape her smart contract to store 3 variables. For example, owner alive. That is, initially it is set to true because it has been, she has written, and so she is alive. And so that's how the timestamp also makes a good need, and why that one is needed. And benefactor address to store the address of Bob's wallet, that is the beneficiary. And the beneficiary, whether he is graduated, initially set to false because he is still studying in the college. And smart contract code would then contain some functions which would be used to modify the state. And so now here, if you look at the observations, the smart contract are not able to retrieve data from the real world. It relies on external services called the oracles. So that is a key point. Like when one is dead, when one graduates, these are all things that have to be obtained from the external world to the cyberspace kind of thing. Oracles take information from the real world and inject it into the blockchain. And so, in fact, it is here the IoT has played a very vital role, and that's how now you would say IoT plus blockchain and many other things are there, and how it would relate even in the 5G world. Hence, Alice could decide on 2 oracles. The first one would periodically inspect death records, and if it finds a record related to Alice's death, it would trigger the set death function. And then the second one would monitor graduation records, would eventually trigger the set graduation function if Bob graduates. So now here, observations continuing. There are what kind of oracles could be there. One is the software and hardware, and another one is the so-called inbound and outbound. The software generally extract information from the web sources. And now the hardware oracles are used to gather data from the physical world through sensors, and that is where the IoT plays the vital role. And so inbound oracles are employed to insert information in the blockchain, whereas outbound oracles are used to reflect in the real world a blockchain state. So for example, oracles used by Alice are inbound software oracles, whereas in other contexts, outbound hardware oracles could be used to let an intelligent locker automatically unlock as soon as a person pays for it by issuing a transaction on the blockchain. So that's how the integration of the payment system also comes into the picture. Note that the role of oracles is very, very important, as their incorrect behavior could have negative consequences. And so now here, if you look, I will go in a quick manner the blockchain in some detail. One of the reasons is that, people will ask what happens post-quantum. All this, if you do, all these are going to be dead, or what is the thing or the other. And so that's how it will give an idea and what is the impact if the post-quantum comes into the picture, cryptography and all these aspects. So this gives a general notion of a ledger. I will not spend much time on this kind of a thing. For example, if you say there is a CD library, one can have a ledger. That means you can say what are all the CDs she has, and what are the CDs B has, and what are the CDs C has, and what has been borrowed from B to A or B to C, etc. And this forms the ledger. What is the reason I am using the word ledger? In a classic thing, you also call the general technology as the distributed ledger technology. Because in all the banks, each one has its own ledger, and that's how you have to come up with whether there is one unique ledger that has been accepted by every stakeholder or not. And if there is a discrepancy, then it becomes a problem or the other kind of a thing. So in a sense, this gives you a ledger. And so now, to give a brief about Bitcoin, because blockchain is a byproduct of the Bitcoin. So now the question that has happened is, it is nothing but identities and signatures. which has public and private key pair, and ledger is a balance of each identity which is saved on the blockchain. So transactions, you can say, I can move bitcoins from one identity to another and serialize the transactions. Why do you need a serialize the transaction? Suppose I have an amount A and I want to send an amount A by 3, and then another one I want to send it again 3 upon 4, and now you see only one of the transactions can go through. So now I have to serialize the transaction so that I can say what is the valid transaction and what is the thing that cannot go as of now, it has to be submitted again, kind of a thing. So serialization is a very important aspect that comes into the picture, and that's also important from a fairness perspective. Because it could be the case at some point or the other, everyone is trying to see that one transaction will not go through. It is something like a conspiracy can become into the picture, and that is where the fairness comes into the picture. Serialization is a very important aspect or the other, and these are all the transactions, they are all logged. There is nothing deletion coming into the picture. Log is persistent, and it is immutable and tamper-free. That because of the hash power or the cryptographic power. And this is a classic ledger, what you would see in a classic bank kind of a thing or the other. And so now here, this is the digital signature, and you can sign this document from your secret key, and you have a signature, and this can be verified from a public key, and then you would see PK is made public and used to verify documents which are signed by SK. SK is private, it is a secret key. And so like that, you would see in the digital signatures and this one, a Bitcoin is a chain of digital signatures. So like you see in the Genesis, I have something like whatever I have encoded as a Bitcoin, and that has been signed by PK Bob, because here it is something Alice wants to move a Bitcoin to Bob. So now here I want to send it to Bob. I use his public key, so only he can decrypt it using his secret key. So then it becomes a signature of Alice and Bob. And so now here, from one signature, it has become two signatures. So similarly here, if now Bob wants to move his coins to Diana, that becomes another signature, and that gets added. And so you go on enveloping this Bitcoin by various envelopes of the signatures or the other. So that also gives you what is the order in which it has been taken, kind of a thing or the other. So now the question is that how does this function look like? So this one is addressed by this, which says that Bitcoin uses the SHA-256, and here if you look at the 256, it gives a finite number of string for whatever you are going to give it, and so this is the one. Now if I take 256 bit, which is this one, for example, if this function, if I take the string ABC, which is C is a lowercase, and here if you take the capital C, these two you can see, you cannot see what is the similarity here, and that's how this is the randomization and all this comes into the picture. And so this is the way the function is going to be represented. And so now the question is that that one is fine, but the question is that is it going to avoid double spending? To use the word double spending, suppose I have the physical cash, let us say 1,000 rupees. I can give it to Madhuranjan, so let us say, and now I will not have 1,000 rupees, only Madhuranjan has 1,000 rupees. And now, if in the digital world copying is free, I have still the copy. The same thing I can give it to Mr. Acharya. So then it becomes that I have used the same money 2 times. Now the question is that how do you avoid double spending is the main question that has to be addressed, and that is what the thing that was addressed by the Bitcoin by Satoshi Nakamoto. So that is the one. So now if you say the double spending the same digital cash asset more than once, impossible to do it in physical cash because it's a mutual exclusion. So now you may ask some people who are quantum theorists whether mutual exclusion is guaranteed in the quantum computing. That I will not answer now. We will only take it at a discussion level or the other. So that's a totally a different question altogether. But in the physical world, it is mutually exclusive. In the digital world, it is coming, everything is available, and so you have to see how you can avoid it, kind of a thing or the other. And so now here, the double spending in the classic sense, what would you do in the classic our banking system? Now if I have this 50 bitcoins, and if I want to transfer, I will go to the bank and say you transfer it to this, like a trusted third party. But I don't want the trusted third party, and that is the question, how do you overcome the trusted third party? And that is the double spending prevention has to be done in a completely decentralized manner. A network of nodes maintains a ledger, work to agree on the transaction order, and now the ledger, I have given you an indication how it looks like, and that is the reason. So now here, you see the genesis, these are all the transactions that were collected, and these are all valid, and you have the hash, and the next block when it is added, you have the hash, and you have the hash, and now if you have the nth one, you have the hash of all these things on the other. Blocks are chained to each other through pointers, hence it is called a blockchain. And then Satoshi used this while writing his software in his code, rather than trying to say this is exactly the blockchain kind of a thing or the other. So now the ledger is, blocks are connected through the hash pointers. Each block contains the hash of the previous block. This hash gives each block its location on the blockchain. Tampering with the content of any block can easily be detected or the other. So this is not good enough to be, this one we will see why. Blocks are connected through the hash pointers. Each block contains the hash of the previous block. The hash gives each block its location in the blockchain. Tampering the content of any block can easily be detected. And now replacing a consistent blockchain with another tampered should be made very hard. That means, so for example here, if you look at it, if you change these transactions, now this hash will not match, and this becomes an inconsistent chain. Now if you want to make it, I have to go on changing all these hashes along with this transaction coming into the picture. This task is very costly, and so this becomes, that's how this you will say that it is immutable, because the amount of effort you have to put is enormously a large kind of a thing or the other. And so making progress, the ledger is fully replicated to all the network nodes. There is nothing that is hidden. And then network nodes group new transactions like 1 megabit, that is blocks are fixed size. Network nodes validate new transactions to make sure that transactions on the new block do not conflict with each other. So the whole block is non-conflicting set of transactions or the other, and transactions on the new block do not conflict with the previous blocks. One is in the same, this one, and also it should not conflict with the other one kind of a thing. For example, if you introduce many conditional transactions, there may not be possible to have it no conflict in the same zone, so it becomes an issue. So network nodes need to agree on the next block to be added to the blockchain, and that is where you get into the consensus problem. That means everyone has to agree, now you are the winner, and so you can add it, because anyone would have taken a block and trying to do that. So that's how it's a consensus. So Nakamoto's consensus was race to solve a puzzle. This puzzle is computationally expensive. Once a network node finds a solution, it adds its block of transactions to the blockchain. It multicasts the solution to other network nodes. Other network nodes accept and verify the solution. This is the way you are going to sign the transaction. So this is a thing, as you can see, each block holds a block header and a body with a list of transactional recently added. And now here you have this one, and you can see there is something that you have to add something as a nonce, and then what is the thing you can add it as a puzzle. So what is the puzzle? So now that is where you say that the block version is everything is clear. A nonce is used in the creation and verification of a block. N bits a target. a threshold of a valid block hash, because it puts a challenge. If something is put on this, what is the challenge that has to be done? And that is how you would say that the first 4 zeros, first 5 zeros, or first 6 zeros should be there, kind of a thing, and the parent block hash it has on the previous block or the other. So that's how the timestamp, etc., kind of a thing. Let us not need it, we know that. And now here, if you look at it, the puzzle is proof of work. So now here, as you have seen, the previous hash and you have the nonce and then doing that. The challenge I showed can be done by changing the nonce. And this is a sequential action. It cannot be done in parallel. That's how it becomes exponentially possible. That means you have to go on trying, increment it, and then see whether I get the hash with the 4 leading zeros, etc., kind of a thing. This cannot be parallelized. And that is the thing. They implement the POW by incrementing a nonce in the block until a value is found that gives the block hash the required number of 0 bits. This is a very costly operation, and it is sequential. It's a purely, highly sequential, inherently sequential, and that's how the CPU effort, it satisfies the block cannot be changed without redoing the work, or changed after it. The work to change the block would include redoing the blocks after it. And so now here it solves that problem or the other. And so now here comes the picture of what would be the, is it possible 2 persons can actually, let us see. Yeah. Okay. So it is possible at some point 2 stakeholders win over. So now it becomes a fork. This is a blockchain for which one person has added this and another person has added this, and this indicates a possible double spending. This is possible. So now here, and that is how the double spending is not completely done away by just doing the sequential ordering. And now if you look at this at this point, and now suppose this guy succeeds in adding another block, and now that gets added, and now here, and this becomes defunct. That means these transactions have to be resubmitted again, and now this becomes the longest chain for which it has to be added, kind of a thing or the other. And so now here you can see, now why do you say that it is valid? From here, if you go to all the way to Genesis, even from here to here it is valid, from here to here it is valid, but now the question is these two, they don't meet, and now, and that is where it is something like a double spending. So now if you add this and it is single chain, now the double spending has been avoided, kind of a thing or the other. And so now that is where it comes into the picture. You have something like how the other attacks are possible and so on and so forth. I will not go into those aspects or the other for want of time. And you can also, this is one other point that what I want to mention, to some extent when a stakeholder finds a block, he need not have to announce I have found a block. And so now he can keep it, and then he would have created the hash, and he would create another one, and so he will add, because it has to be the longest chain, and now because this is the one which is valid here, and this gets added, and this gets defunct, and now that you see that all the work, whatever he had done, becomes completely defunct, kind of a thing. So limitations, you have a high transaction confirmation latency, probabilistic consistency guarantees, very low TPS, like MasterCard has a huge number, whereas here it is the average of 3 to 7. And I think my colleague who will show the scale up, how they have scaled up, etc., that's a different thing. I will not talk there. And so new block is added every 10 minutes or the other. So in the blockchain challenges, you have one is the architectures have to meet the enterprise requirements. So now here, if you look at it, can I just adopt the blockchain as it is for all the enterprise requirements? What are the enterprise requirements? I need a settlement finality. I need performance. I need speed and scalability. Now if you see the settlement finality in the context of blockchain, in 1 hour, perhaps it is probabilistically, you can say it has reached a finality. And so now here, if you are not able to settle finality, enterprise people won't like to have it at all because it is something I cannot give an answer. So now here, similarly, governance, privacy and confidentiality, of course, compliance and safeguards kind of a thing are there. So now here, if you look at it, you have the blockchains are trustless, always require some kind of trust. And they are 100% secure are not automatically more secure than other systems. I will not go into there because one of the main reasons is that in a blockchain, if you enter it, then you are a king. Whereas in the classic thing, it is almost like an onion layer. If you are in first layer, the other persons can sense something is happening and they can stop. Second layer, third layer, fourth layer. Whereas here, once you get into that, you have serious problems and then you have to do that. And of course, like the classic computer science, garbage in is garbage out. If you don't give a proper input, you will always get a garbage kind of a thing or the other. Blockchain architectures, that's how you have something like a permissioned and permissionless. Bitcoin is a permissionless, and now the main operations are read, write, and commit. And based upon this, you have various classes of architectures. One is called the permissionless, which is read is open to anyone, write is to anyone, and commit is to anyone. Whereas in the public, which is permissioned, write is only authorized participants, and consortium, it's again restricted to the consortium people, and whereas private, everything becomes this one. So unless you have permission, governance and grievance redressal becomes extremely difficult, and that is where the enterprise requirements have to be met. You go for this kind of architecture to see whether this one is going to be satisfied at all or not. So like that, this is the classic architecture, which you say distributed databases, distributed ledgers. What is the difference? They can have adversarial model. That means, and you have the blockchain, you have a data structure, and then the whole thing comes into the picture where I have the immutability and all that comes into the picture, and then you have the permissioned blockchain where only permissions are there, whereas blockchain is a permissionless kind of a thing. So you, within this, you can have varieties of things, and then you can simply ask a question as to whether you need a blockchain or a database would essentially do. You can just say, do you need to share the data? If you don't have to share the data, you don't need a blockchain. You can just do away with just a simple database. And or these, there are multiple writers, and if there are no multiple writers, you don't have to worry about that at all. And now then you can ask, when the multiple writers are trusted, if they are trusted again, you don't have to worry about it. And then similarly like that, you can go on saying under what conditions you can go for a blockchain, under what conditions you don't have to go for a blockchain becomes very clear or the other. And so the technological challenges, as I mentioned, consensus protocols. There are varieties of consensus protocols that have come into the picture. And now Ethereum, which was working on POW, is now switched to POS completely. And the scalability and performance and fairness requirements and post-quantum requirements. Fairness requirements, whenever you want to change scalability and performance, fairness suffers. And so this is a key factor. You don't know what happens. For example, if you compare with the Bitcoin transactions and Ethereum transactions, the number of forks that are created in Ethereum, at least when it was using the POW, was enormously large. So now you don't know what the things are, kind of a thing or the other. There are many other things. This is another structure, the same thing coming into the picture. Now let us go into the scope of applications. And so now here, this is the classic one, so I will not repeat it. And now is a trust management framework. Trust is a subjective, non-transitive notion. That means if A believes B and B believes C, A need not have to believe C. That is one like the web kind of a thing. If I believe one and if I believe another one, it does not have to do that. Blockchain, you have distributed, transparent, continuous auditability. In the first generation smart contracts are all financial transfers. and then you have a varieties of applications. I don't think there is anything that is left out, but the thing what you have to see is that the supply chain is one of the things which have adopted the blockchain to an enormous extent or the other, including the private consortium or the other. Finance, trading, for example, I will look at a DAO or a decentralized autonomous organization, online lotteries, smart contract based pension funds, and so on and so forth. Let me just give what would it mean by a decentralized autonomous organization? Organization running on a fully democratic way. So now it's a group of people who have common interest. They want to generate money for the shareholders, need to follow the rules of land where it is incorporated. You can even take the example of the recent bank of the SVB in California. That's a different issue altogether. Group of shareholders who represent ownership in percentage of the capital. Shares can be transferred or transfer of ownership. Board of directors with a CEO to run on day-to-day affairs, bylaws, memorandum of articles, article of association, and DAO is the digital version of this. So now here, executed by thousands of people through consensus, DAO runs on a blockchain, Ethereum blockchain, let us say written in a language called Solidity, and each action or vote is represented through a transaction on a blockchain. Members are represented by addresses. Addresses can be owned by people, robots, IoTs, or even another DAO. Functions automatically without any central control. Each member is given a token representing his shares in the DAO, can be used to vote in the DAO for any of the actions to be taken. Token is nothing but another contract running on the blockchain. So full democracy, voting could be delegated, that is a proxy. Can raise funds through crowdfunding, issuing tokens and shares to those to pay to DAO. Paying and issuing can be taken in real time, like many which were taking more than 60 days in a physical organization. So it could be, now you have saved a lot of time or the other. So now I will not go into, there have been problems which I will address. Now I will come back to the classic input tax credit in the GST. I don't know how much people are happy with the GST implementation or whatever it is. For example, a simple understanding of the input credit, you have a tax credit, a tax paid on some components, let us say ABC, and now the output tax with, let us say he has paid 450, he can take a rebate of what has been paid on the components and things like that. Now the question is that how do you actually model it as a smart contract? So now, one of the simplest thing, what you could do in this simplest case, you see the arrows have become rigid. There are no multiple arrows. That means there are no multiple writers. And now here, if you come for the simple case, there is something like the ERC20 token, which itself has a problem when you have multiple writers, and that can be done without problem. So now I have shown in another paper, which I will not go, when you have multiple writers or concurrent cases, the ERC20 is not correct, is incorrect. How to overcome that? I can find a procedure to say under what conditions the constraint have to be satisfied so that it can still go, that means the performance can go, etc. kind of a thing. Similar thing we are trying to show that input tax credit, even if it is multiple, what do you mean? That means this could be shared by many people. That means that somebody can take 20 rupees out of that and 80 rupees somebody can take over it, and that becomes concurrent transactions. How many persons are doing it, it becomes concurrent, and that is something that has to be implemented in a nice manner. I'm not sure what is the way that one is happening in the current context or the other, and this is where the smart contract will play a role, because it guarantees that there is no possibility of cheating unless this tax credit has been paid, invoice has been paid, you will not get that rebate kind of a thing. Now, based on some paper, you may get a rebate, and so there may be a disturbance in the ledger kind of a thing or the other. And so you have various other applications like remittances, the supply chain, agricultural supply chain, and traceability, and secure contract negotiation, etc., including an auction kind of a thing or the other. And so this is one of the major things, as you know your customer. So for example, if you see identity becomes an important thing, one of the blockchain is the sovereign blockchain, which enforces the identity kind of a thing. Now the question is that using that, would it be possible for you to have only one KYC rather than multiple KYCs times kind of a thing or the other, and then personal data management and notary services, healthcare, land management, etc., kind of a thing. Of course, in CBDC, you see as an alternative, the technological guarantees like double spending avoidance, traceability, have prompting, and also CBDC has something of a different nature because that affects the economy, and how, for example, Cambodia has implemented a CBDC in US dollars, not in their currency. The question is that then nobody may be using the local currency. And so now Indian rupee, if we have a CBDC, which is now restricted to only a finite number of banks, if it is distributed across the whole country, maybe if our user interface is very good, maybe rupee can become win over many other currencies to say that this is much easier to do and share, and money laundering can be overcome, and also privacy can be maintained, and all these aspects will be the challenge from the technological perspective of implementing this. Once you have a CBDC, what is one of the reasons for CBDC is it has to go to everyone in inclusive way. For example, even in US, 20 million people don't have bank accounts either for wantonly, or they don't want to, or they don't believe it, or whatever that one is, kind of a thing or the other. So that is one of the things, inclusivity as well as trying to overcome the money laundering issue. So you have to put in a hierarchical manner both privacy as well as money laundering, without which it will not be accepted. It's very important. A currency has to be accepted by the society. It is not the technology people who would accept it. It's the society that has to accept it. And now it has to be made in such a way, when they want privacy, they have, and when the government wants money laundering, it is there. And what is the level at which it has to be done? It has to be done in a very nice manner, kind of a thing or the other. And so this is another important point which I will not go into, like water markets can also be effectively put on a blockchain to say that how water can be traded. For example, this happens in California from one area to another, how the arid areas can conserve and get water and money, like that kind of a thing or the other, and varieties of things or the other. These are something which I will, this one. So scope. So now here, the important thing which I think is smart contracts, correctness is a very important aspect. As I mentioned, like the Oracle. Programming languages, there have been many, Solidity, Go, DAML, and so on and so forth. Well-known attacks from exploitation of language features. The one example of what I gave of the DAO was $50 million was taken away by somebody announced there is a vulnerability, and then they got over it. And existing approaches for this, these are all based on static analysis, transformation, etc. kind of a thing. Even people use machine learning. So machine learning is a post facto. That means that after one has lost the money, you do that and say why we have lost it. It has no value, but by then you have already lost the money, kind of a thing. And so the only thing is the runtime framework, glimpse of solutions and lifting solutions to declarative notions. That means how you can ask the programmer to give little bit of that kind of a thing. And so now here if you look, and this is something important what one has to understand, smart contracts on shared memory, because blockchain is a shared memory across many processes. This becomes the challenge of distributed programming. Even today, distributed programming correctness is a real challenge. And now here you say how they are the same. Accounts using smart contracts in a blockchain are like threads using concurrent objects in a shared memory. Contract state is nothing but object state. Call or send is nothing but context switching. Reentrancy, which I will not go, uncooperative multitasking, invariance are something like an atomicity, and non-determinism is something like a data races. People who use Java, data races common to them, but that's a different issue altogether, a kind of a thing or the other. So now how did we solve it? So one of the major problems in the concurrency is everything is done if you do it in a disciplined way by mutual exclusion. Only one person can act at a time. So now how do we maximize the parallelism? We did it from a programming language perspective long back, and using the same thing, what we have tried to do is trying to show that if you use different declarative classes like non-inherent access pattern, parallel constraints, and so on and so forth, you would be in a position to derive what is called a solidity plus plus, but solidity plus plus can itself be transferred to solidity, and you are going to actually, this is something declarations plus solidity program is nothing but the solidity plus program, and then you have a processor, and you say that it's a secure solidity program, and this is what it would look like. Or the other, the advantages would be simple declarations are intuitive and can be handled by a general programmer in line with the understanding. Runtime checks are added to the program as per declarations. These are all automatic, allows programmer to debug at the source level rather than at a EVM level. So this is something, if you ask people to debug at an assembly level for which you don't know what the source looks like, it becomes extremely difficult. And then using this kind of a thing, integrated development for solidity, characterization of decidable fragments, and so on and so forth. And so now another question comes. There are many languages. For example, if you look at Ripple, there is no smart contract. They have a blockchain platform. So now how do we enrich to introduce different smart contracts? It is done through what is called the hooks. Now if you want to add some programs at those points to enrich the smart contract, now under what conditions the guard should be satisfied is something that needs to be worked out. And now we can also use something what we called as a proof carrying code, which is used for a sequential context or the other. So history, I think I will skip the history because it goes to Roman history, keeping the ledger. So now let us go to traditional contracts versus the small contracts. I have, I think, 5 more minutes, and that should be good enough to say that. Smart contracts, courts, lawyers, and consumers. An automatically self-performing smart contract can truly exist in a pure virtual world, but becomes more complex when connecting to the real world, necessitating interfaces between the software and the reality. Interface starts with oracles providing real-world parameters for coded self-performance and extending to other links to ensure contract content validation, contract legality, lawfulness of contract purpose, and measurement of contract. Complexity has 2 significant aspects. Now, question you can ask is it more or less work for lawyers and judges? That is something you have to ask. Enhanced reliance on burden of proof, enhanced advantage to party expertise, and an enhanced significance for party asymmetry. So in the electronic platforms and the smart contracts, suitability of the electronic platforms as contract substitutes, and hope for the expanded use of platforms if they are secure, resilient, and adaptable, capable of continually and swiftly accommodating legal requirements. If you don't have, the electronic platform will not be accepted by the society. So now let us see what are the conflict areas between smart contracts and the traditional contracts. Flexible, enforceable legal contracts versus firm, self-enforcing smart contracts. Traditional contract is flexible, while smart contracts are rigid because they are immutable. Once the smart contract terms have been programmed into the code and executed onto blockchain, there is no longer a need of reliance on the willingness of the various parties to perform. Code is law. And so smart contracts are performance-based and ensure a greater likelihood of performance than conventional contracts. And so now the second one is different aims of legal contracts and smart contracts. Smart contracts does not challenge the traditional rules of contract. However, their self-enforcing nature does, because the traditional enforcers, courts and arbitral tribunals, might be helpless in providing an ex post solution because it is rigid. This is the essential conflict between the immutability of the smart contracts. Smart contracts have been called the first real disruptive innovation in the legal profession, and it is said that the technology will eliminate or at least drastically reduce the need for lawyers, paralegals, judges, or arbitrators. So now here, the computer code versus natural language. While programming language may in fact remove linguistic ambiguity, it will remain helpless in relation to changes of circumstances, lacuna, and questions of equity or good faith. This is something, good faith is a very important aspect in the contract law. Consumer protection law and the smart contracts. Another element of conflict between smart contracts and traditional contract law is the protection of weaker parties, an idea that traditional contract law contains and which became utmost importance with the rise of consumer protection. Another highly problematic area is the application of the unfair terms directive to smart contracts, an area which is important for the determination of the content of a formatted contract. That means here, unfair terms directive clearly states that the fact that certain terms have been individually negotiated shall not exclude the application of the unfair terms directive. This becomes a challenging thing in the context of grievances and etc. Law of excuse for non-performance. The law of excuses for non-performance is the result of a long and complicated history. The right of the creditor to performance is, however, not absolute. Every legal system recognizes that performance may be frustrated in various ways without thereby making the debtor liable for breach of contract. And so general analysis of the doctrine of excuses for non-performance based primarily on the draft common framework as a set of model rules drafted by the European legal fraternity on the basis of extensive comparative research amongst the legal systems of most European countries. And so now here, one thing, let me just spend 2 minutes in the various definitions. I will not go into. There are various things you could see that, and is implemented in software and by a mixture of both. And now you can see which are automatically executed by a machine, and now again do not need artificial intelligence to that. So this is something I want to highlight, are not merely digital contract, nor they are entailing AI, and that a smart contract doesn't think like a lawyer does. Instead, smart contracts enforce the lines of computer code which they have been programmed for. So smart contracts do not need AI to work. A smart contract should thus be perceived as an automated mechanism which performs its defined functions as certain preconditions are met. In fact, even in Szabo, he never said about AI, which is the start for the smart contracts. Note that smart contracts are based on logic of cause and action that are predetermined by the smart contracts author, and so that's how it becomes a very important thing. And now if you look at a summary, you can see consisting of formalism, fixed and hard rules, certainty and predictability, and what is the context, blend of fixed rules, standards or open textured rules, or ensure a degree of fairness or justice. In fact, fairness and justice, even in ML and AI, is one of the main things comes into the picture. If you look, what is the ethics in AI comes into the picture or the other. For example, if you have a loan, and now in the data you don't have people who are of the other one class of society, they will be completely omitted because that is not part of the data. It's a chicken and egg problem comes into the picture or the other. So to conclude, so in the era of digital transformation, the challenge is to transform contract to smart contracts. What can be transformed, what cannot be done, how much decentralization can be done, how much decentralization cannot be done, and how the middleman can be avoided, and then automation of payment systems, including a DC-BDC kind of a thing. Blockchains and smart contracts, you have the complete provenance and traceability possible on the smart contract. Again, one has to see that the power of smart contract languages has to be limited, and you have to be sure that the smart contract languages are executing as intended. If you do not do that, you don't know when the error will arise and how much you would lose. It becomes an extremely difficult thing, and classes of DLTs with families of smart contract languages is one of the things what one has to think about. And of course, it's an exciting interdisciplinary area of technology, economics, law, and society. With that, I will stop here and thank you for a patient listening. And I'm open for any questions or comments.
Can I have a question here? Okay.
So technically, in my view, AI and smart contract have no role. Okay? So now technically you can also call in the current terminology of the compiler also is an artificial intelligence system, right? Because it correctly executes it. So AI has no technical role. AI has a role only for providing proper interfaces to the persons, and that's where it's very important. Whereas otherwise you don't have to have a blockchain. So the blockchain, if you want to have a blockchain, you have to answer those questions to say that are there going to be multiple writers? For example, in the context of a simple GST example, I said, if there is only one person who is going to take this input tax credit, there is no need of a blockchain. Database will do. Whereas now, the same thing can be used by multiple units of the owner concurrently, then you need a blockchain because that cannot be handled very easily in the context of a pure database kind of a thing. But the challenge is, like as I already mentioned, all contracts cannot be transformed into an executable smart contracts, but they can be done provided you introduce many oracles. Some of the oracles may be even human beings.
There is a question here.
Yeah, hello, sir. Thank you so much. Vineet Sachdev. I come from a non-banking finance company. Like you mentioned, there can be really many frustrations which can occur in a ordinary conventional day-to-day contract getting executed. Is there any, looking at the present legal scenario, and there can be delays, there can be frustrations in any sort of debtor creditor or any sort of trade contract. Is there any flexibility which can be built within your smart contract to allow that?
So you see, one of these classic cases is the application of blockchain for supply chain. So now, for example, people have tried, particularly IBM, even perishable food, how it can be transferred, because if the delay happens in the customer phase, either for payment or something like that, you lose a lot of money or the other. And that it can be triggered automatically to say it has to be finished, and it can be done quite quickly or the other. In supply chain is a good example wherein you can also enforce so-called what I mentioned earlier, some notion of an AI, what is the probability this has to be triggered early kind of a thing or the other kind of a thing. I don't know whether it answered.
No, I understand what you just said, sir. I'm thinking in several contracts, at times, if we are extremely rigid, because there's a cause and effect and rules, it can lead to disputes which, which will keep occurring very, very frequently. Whereas in conventional contracts, you give it a little breather and you are able to still maintain the validity of the contract, complete the transaction, maybe with a little delay, maybe with a little adjustment. Can a smart contract also accommodate that?
Yeah. Sir, let me first tell, first is how much the contract is to be transformed into the smart contract. So in the question of the smart contract, it can take into, now something you have found, there is something wrong because the rules have changed from the government. It has to be this one. So now, again, it goes through the consensus. I can generate a new contract to say that the old contract is now defunct, From this timestamp onwards, it is the new contract that comes into the picture, and the old data is no longer applicable as far as this data is concerned, kind of a thing. That is the way the code can be done, kind of a thing or the other. For example, if you see in the Bitcoin, you always say it is a trust which is obtained from untrusted people or thieves will lead to a very trusted agent or the other. But the question, if you look at it, where is the trust? Trust cannot be, can only be relocated, cannot be created. Where is the trust now in the Bitcoin? His question is that one is the underlying crypto mathematics. So now if the crypto mathematics is shown to be false, then the whole thing collapses. Okay? And then it is not ending there, that is the theory. And now that has been transformed into a programming language, and if the transformation of the programming language is not actually completely equivalent, then there can be a problem or the other. And so now, and then the hardware. Now that lots of people use blockchain, there is no need of a specified, only a small persons of some particular company manufacturers, you can use off-the-shelf machines, so that the trust perhaps is much more because lots of machines are being used. The trust is on hardware, mathematics, and the programming language. And so these are the things, trust have been relocated, and that's what one has to see that there. Like that is where in the quantum cryptography comes into the picture. Now the question comes into the picture, what happens? That is one aspect that one has to look into. Another aspect what one has to look into is that assuming I have a quantum cryptography, is it possible all my characteristics of the blockchain by the performance and this one, will they still satisfy when I construct many of these things? So this becomes an important thing to say, what would be a blockchain in a post-quantum cryptography?
So just to clarify, you mentioned when there's so in an existing smart contract, if one of the parties wants to change something, they can propose a fresh consensus and a fresh contract will be created therein.
And this has to be consensus.
Consensus
all the
driven,
stakeholders have to agree.
Yeah.
If they don't agree, it won't go there.
Or it could be a weighted consensus
Yes,
as well.
yes. And like that's where the consensus becomes, so a new can add a new smart contract.
All right, sir. Thank you.
Excuse me, sir. The smart contract is definitely fixed in hard rules, but it is.
Can
Uh,
you repeat?
yes, sir. Here, sir.
Yeah.
It is definitely very rigid, but it is not flexible. So it definitely rules out corruption. But sometimes what happens in contracts, some clauses we do minor deviations, so we accept it. But in smart contracts, those will not be accepted, and ultimately contract fails. So
No, that is what in the last point what I made, the difference between the classic traditional contract and the smart contract. If there is something like a performance, the performance got reduced because he had a COVID. There is no way that the smart contract knows. It will just say his performance was bad. And so like that, and then you can say what is the conditions in which, like earthquake has happened. So there is no way to record that kind of a thing. All this has to be done in a separate manner, and so that is something what you have to gear it into the smart contract through the oracle, which one would say if this condition happens, then what is the way things have to be dealt with, kind of a thing. By unused kind of an oracle can be used, brought in at a later point, before itself one can put it in.
So, no, actually, for this our vendors are to be educated because they have to be very strict according to the contracts. And but sometimes we adjust, because for small points you don't reject the tenders, and whereas smart contract will reject those things. And so it may not be suitable for Indian conditions. That is what I'm saying. Because our vendors and our people are not that rigid.
The large spectrum, how they are being used. For example, if you say this much money has to go to the agricultural people, so all the farmers should get this much money. Now can I record? And the banks have to give this much loan to the banks. Can I now record it on a blockchain? Can it become transparent? And all these things at a higher level, you would say that how much money the state government has returned to the bank, what was given by the bank. Now if you look at it, whole the economy of them will become completely transparent.
Sir, I think it will be it will for Indian condition it will be a combination of smart contract and traditional contract that would work.
Yeah, technically, as I already mentioned, one of the oracles could be a human. Now, like what I said in one of the simplest example of a will, I had said he has graduated. So that is something which is found. Similarly, you can say, is there an oracle of a higher order, or let us say some vigilance officer who now gives an input, then you can do something else kind of thing.
Okay, thank you, sir.
Okay, we have time up for the question for the first lecture. Thanks a lot, Professor Shyam Sundar.
Thank you.
Thank you so much, sir. Now I would request Dr. Madhuranjan Kumar to come over the stage and hand over the memento to Professor Shyam Sundar. Moving on to the next lecture, it will be given by Dr. Amit Kumar Vishwakarma on the topic Introduction of Smart Contract. Dr. Amit Kumar Vishwakarma is the blockchain consultant at the Procurement Research Center of Arun Jaitley National Institute of Financial Management. He holds a doctoral degree in electrical engineering with specialization in blockchain technology from IIT Kanpur. He has also been a keynote speaker in blockchain events such as CRDF Global, APC Ministry of Textiles, Tsinghua University Blockchain Association. His research area includes blockchain technology, tokenomics, CBDC, and smart contracts. So I now request Amit to please deliver his lecture.
आपके इसमें कट रहा है 102 का बोला उसको 102 का तो है ठीक है
Thank you so much, Soumya, for a nice introduction. So first, I'd like to thank Dr. Madhuranjan sir, so giving me the opportunity to speak on this stage. And so today I'm going to talk about a basic of blockchain technology and the smart contract. As sir already discussed almost a lot of things. So I'm not going to talk about all those things what sir have spoken already. But a little bit in detail I will talk basic of those things, basic about the blockchain technology and the cryptocurrencies and the smart contract. So first I'd like to start about this confusion, like the blockchain technology and cryptocurrencies and the smart contract, what are all these things? Okay. So a lot of people are not from the same background as we are, like from the academics and from the research team. So the blockchain technology is just a technology. So the applications are like very wide. So cryptocurrencies are one applications, and the other technologies that we discuss, those are the applications on the blockchain technology. So the crypto is one of the applications. So we are not here to discuss about the cryptocurrencies or Bitcoin or anything that is not related to our topic. So the conference is particularly about the smart contract, and the smart contract is actually not related to the blockchain. Blockchain is kind of technology, and the smart contract is a contract, like a simple contract we know. A contract, a simple contract, traditional contract is on paper, and the smart contract that we talk about, it is kind of a computer code, and that is a self-executable when certain conditions are met. So it is kind of, it will eliminate the third party. But if we'll talk about in the blockchain context, so the blockchain is the one platform where the smart contract can be implemented by using its properties of the blockchain, like we have immutability and scalability and decentralization. Okay. So first I would like to start about the blockchain technology, then how it got evolved, and then I will discuss about the smart contract in detail. So as we know, like in 2008, a person or a group of person we don't know, so who introduced a blockchain into the market. So it was on a paper called Bitcoin, a peer-to-peer electronic cash system. So the paper was written in 2008, and the application got started in 2009 in January. Okay. So what is actually a blockchain technology? So blockchain technology is a kind of distributed ledger technology. So where the data is not stored at a single place, it will be stored at a lot of places. Suppose people in the room, almost 150 people are there. So all are involved into the network, and the data, there will be no third party. If a transaction is happening, then the people into this room, they will handle everything. Like the bank does, bank will handle all the transactions, they will maintain the ledger. So in terms of blockchain technology, this will not happen. In terms of blockchain technology, all the people who are present here, they will participate into the verification of the contract, verification of the transaction, and storage of the transaction, and all the thing that is happening into the network. People are responsible to do that. And for that, the blockchain technology, they have introduced a concept of mining. So people who are participating in the mining, they will get some mining fees for that. So they will not do anything for free. People will get incentive. And how they will get incentive? For that, in this paper they have mentioned, we have almost 21 million. We have actually 21 million Bitcoin into the market. And those network, they will self-produce after some time. Once a block created, then they will generate few Bitcoin, and they will give to the people who are participating into the network. So why this blockchain got introduced? So there were some problem, like how to perform a digital currency transaction between users without any intermediary. Like we have right now, we have a bank, and a lot of people, I don't know, maybe have faced the same problem that I have faced. If you are going to the bank for any transaction or doing anything, most of the time, if you will go in a state bank, then you will find the transactions are like their server is not working, and you will have to wait for some time before they proceed those things. So I think these are the computer codes, so they will never complain anything such like that. So once a transaction you will initiate, the computer codes, they will automatically do all the things that is required for completing a transaction. So what is a blockchain? So blockchain is immutable, like the blockchain data cannot be changed. As sir said, like the blockchain is a series of blocks that is connected through a chain. So that chain is called a hash, and I will discuss about the hash in detail. So those hashes are those blocks are connected through the hashes. Like almost we have, right now we have 72 lakhs blocks. And if you want to change into one block, like if you want to change a single transaction, then you'll have to change all the blocks that is after that transaction that is stored into the blockchain. So practically it is impossible to do that thing. So I think if you own 51% of the network, then it is possible, but practically that is not possible to own a 51% into the blockchain. So the blocks, once a block is added into the blockchain, it cannot be deleted. And each block contains a hash value of the previous dependent block, so they are connected through a hash value. I'll show that thing. And all the blocks are chained and they are linked, and the entries are mutable and reversible. And data is tamper-proof, as all the data is stored into the blockchain, and that is, the data is in hash form. If you want to change a single data, then that hash value will get changed, and you cannot add those things into the block until and unless all the people will agree on that. And that is practically not possible, so data is tamper-proof into the blockchain. So if any node try to modify a block, then the entire block will be invalidated. So how does this blockchain work? So I think sir explained it very well, so I'm going to skip this one. So this is how a block looks like in a blockchain. So these are the transactions in a down, if you can see. So, yeah. So the transaction will, here transaction will get initiated, it will not get completed. Okay, the transaction will get initiated and it will happen. And all the transactions, they will calculate a hash value of all the transactions, then it will be chained into, like it will come into the single Merkle root. So how many transactions? Like almost 2,000 to 3,000 transactions it will contain in a single block. So if you want to change a single transaction, so those single transactions, if you will change the hash value from this Merkle root, it will get changed. And you can see all the blocks are related, like this block is connected to this block is connected to this block from this value, the previous hash. This previous hash is the hash of this whole block, okay? So once you will come to this block, so here also they have previous block, the hash value of this block. If you want to change a transaction into this block, then you will have to change all the blocks that is added into the blockchain after that block. And that is practically not possible. So that's why we call this is tamper-proof, and the data is irreversible. The transaction is irreversible in the blockchain technology. Okay. So this is how a hash look like, a simple, I have taken SHA-256. So you can see as I have written my name here, AMIT, A is capital here, and this is the hash value of that one. And if you can see, I written here also Amit only. So, but this A is small, and the hash value is totally different from this one. So this, how this hash is calculated, there is a mathematical computation for that, and I'm not going to discuss about those things. But yeah, online if you are going and if you are checking this, if you will write into Google, like how to calculate the SHA-256, and you can write your name and you can get the hash value of that one. And then again you can change that. A single bit also you will change, the entire hash value will get changed. So this is how this get added, like all the, this transaction they will add, then calculate hash, again that. This is just a simple example of 4 transactions, and in a single block in a blockchain, it will contain almost 2,000 transactions, okay? So in a computer, like this is how, I think, okay. So this is how a block will look like. So they will have hash, the capacity of a block, and how much distance they have traveled, like from Genesis block, from block 0 to till that block, and how many Bitcoin transaction is happening into that block, what are the value, what is the value today, and average, these are things. But what are few things that we'll discuss about the fees, how much fees it is, it will take to complete a transaction, and what are the Merkle root that we discussed, difficulty, nonce we'll discuss, and the reward we'll discuss. And the block height also we'll discuss, okay. And the miner, obviously, miner is very important in this case. So as I said, the miner, they are responsible for adding a block into this blockchain. So if I talk about the Bitcoin, so I think this is not visible in that, but here the Bitcoin is the transaction of, the number of Bitcoin transaction happen in this block is around 12,699 Bitcoin. And the fees was 0.3198 Bitcoin. So if you will calculate in a rupees, then this 0.3 will come almost, I don't know right now value, but almost 10 lakhs it will come. And the transaction happen is around 12,699, and you can multiply with almost 25 or 30 lakhs, some, I don't know exactly the value. So it happens in a billion, I think, and the value, the fees is 10 lakhs only. So I think this will be a cheaper if you will talk about in a financial terms. And this nonce and difficulty, what are that? So this, how will find the person who is going to add a block into the blockchain? Because that block, that person will get a lot of rewards when he is adding a block into the blockchain. So for that, there are some certain calculations they have to, some mathematical puzzles have to solve. And this difficulty and nonce are the value that they can adjust to compute those blocks. Okay. And the rewards is 6.5 Bitcoin right now. Once, like when the blockchain started, like the Bitcoin started in 2009, it was, I think 50 Bitcoin for a single block, like the reward of single block addition, and then it came, it is going to, it is getting half after certain years. I think in 2041, all the Bitcoin will get exhausted, whatever into the network, the Bitcoin is created. But yeah, those Bitcoins will be into the market. It's not like after 2041, the Bitcoin network will get collapsed. Okay. So the miner in this case is unknown. There are few miners that is very active in the market. So how this blockchain process work? So the first, the transaction will transform into the hash, then that hash of the whole block is created. In a whole block, there are a lot of other things, like in a whole block, there will be a nonce value, the Merkle root, the time stamp. So these are all things, the block hash will get created in that one. And then nonce is appended to the hash and hashed again. And then resulting hash is compared to the difficulty level. This is this thing people have to solve in case of becoming a miner and to add a block into the blockchain. So these are the, this is a computer code. It is like the difficulty level in starting it was very less, and now this is getting increased day by day because a lot of people are involving to that. Then they have increased the difficulty level. But yeah, in 2014 it will be a lot difficult. Right now we have. So if not, then the nonce is changed, then trial and error, they will calculate the target hash value, and once they will reach that target hash value, then they will get a chance to add a block into the blockchain. So the hash of a header becomes a new block, and then that block will get into, will be the part of the ledger. And the miners will get reward into that. Okay. So I think these all things sir discussed, as a trust protocol, what are the property that blockchain holds. Yeah, so there are certain blockchains like the blockchain type. So we have a public and open. So right now we have in Bitcoin, and we can do the online betting and the video games that we know, the play to earn kind of things. So these all things are implemented on public and open. So like we have a Bitcoin and Ethereum. And then we have a public and closed. So the data will be public, and the permission will be, there will be some permission. Who can see the transaction that is happening, or who can see the ledger into that. For that, the voting system, the voting records, the whistleblower, those people are there. And for private and closed, so we have certain people who are responsible for adding the block into the blockchain, who can read and who can write, who can do all those things. And in that, the example are like in India, we have national defense, law enforcement and military, and we have a tax returns also. Because these are the things that government need a control of that, so they cannot make it the data publicly. So these things we can implement on a blockchain also, that will be private and closed. And next is private and open. So there are supply chain, the government financial records, so corporate earning statements. So I am working on a supply chain, so I am going to talk about more of private and open. So what are the consensus algorithm? This consensus algorithm, these are the some conditions that I said. So once they will reach to a consensus point, like they will reach to agreement, so this process will get automatically happen. So what are those mechanisms to reaching to the agreement? So the first one is the proof of work. In proof of work is like it is a piece of data that is difficult to produce, but easy for others to verify and satisfy the certain requirements. So in case of proof of stake, we have asked miner to prove ownership of a certain amount of cryptocurrency, means they'll have to put some cryptocurrencies on a stake to become a part of that mining team. And then we have a Byzantine fault tolerance algorithm. So here database replication protocol used in a closed blockchain with limited nodes. So I'm going to discuss about not any of this, because we are not, in a smart contract, we are not using the consensus algorithm, so we will reduce the complexity, computational complexity in our case. Okay. So this is a very interesting thing, because most of the applications we can see, if you'll go online, if you'll search the blockchain application, you'll find almost like every application is people are building on a blockchain. Okay, but there are very certain points where we actually need a blockchain. We cannot use blockchain at everywhere. Like people, most of the companies, they are launching blockchain solutions. So they are providing solution for everything. So first we'll have to check whether a blockchain is required for or not, and if a blockchain required, then which blockchain will be required for that. So the first one is, do you need to store the states, like the traceability, I can say. If you need that, then we can proceed ahead. If you don't need the storage state, then we don't need a blockchain. And if there are multiple writers into that network, so suppose there are a network of 10 people, and if in that network only one people is writing, then you don't need a blockchain for that. Then only a simple database will be sufficient for that. If there are multiple writers, then can you use an online trusted third party? If you can use an online trusted third party, then you don't need a blockchain for that also. But if you cannot trust anyone who is present online, then you can use a blockchain. And if all writers are known, if they are already known, then you can see if all the writers are trusted also. If they are all trusted, then you also don't need a blockchain. If they are not trusted, if the public verifiability is required, like in terms of government supply chain we see, or the government who they propose some scheme and people want to see. So for those things, we can use a public permission blockchain or private permission blockchain. And if all writers are known, if they are not known, then we can use the permissionless blockchain, like in terms of a Bitcoin and Ethereum network. So no one knows anyone, and people want to make a transaction into the network, then we can use a permissionless blockchain for that. So this is how blockchain get evolved. Like in 2009, the Bitcoin came, and in 2014, the Ethereum came, and after that, a Hyperledger came. So first people in starting the application was only the cryptocurrencies, and it was open and permissionless. Then we came for other applications also. When the Ethereum came, and then this whole thing got changed, because most of the applications are built on Ethereum, or right now we can build on Hyperledger also. So Ethereum is, it is also open source platform like a Bitcoin we have, blockchain we have. It is also a decentralized application. On Ethereum, you can write code, like the smart contract we are talking about. So in terms of blockchain integration, this is smart contract. In starting, it was implemented on a Ethereum network. So in Ethereum network, they have Ethereum virtual machine. You can write your code, and you can execute that code, and automatically the transaction will happen. Like any application you want to do, and you can do online on a Ethereum virtual machine that. So this is kind of piece of code. So it will be run exactly as a program. So once you are running the program, and once it is into the blockchain, then you cannot change that program. You can write another program, and you can run another program, but you cannot override that smart contract once you have written and you have deployed on the blockchain technology. So Ethereum, so it is kind of an internet where money and payments are built in. So money and payments are like, right now we also have online banking, but this one is very different. Here you don't need any bank or anything, so you don't have to wait for the servers and something. This is kind of the people who are involved into the network, they will take care of everything. And you can build another payment system, like we have a CBDC right now. So people are talking about CBDCs. So this also you can build on Ethereum network. And this internet, like where user can own their own data, and your app don't spy and steal from you, because this app is not controlled by a single person. So this app is controlled by a group of people that is participating into the mining. So here everyone have access to an open financial system, and the internet built on neutral open access infrastructure controlled by no company or a person. So it will be controlled by a group of entities, like group of people that is participating into the network. So the contract, smart contract, so it doesn't come after a blockchain, like most of the people, they relate the smart contract with Ethereum or with a blockchain. So it is nothing related with the blockchain. So the smart contract was discovered very early, like in 1994, but people were not talking about a smart contract because there were no trusted platform, we can say, where you can implement the smart contract and it can be as much secure as we have right now. But now we have blockchain and we have Ethereum, we have Hyperledger. We can build a contract on top of those applications, which will give the certain property of blockchain or Ethereum or the Hyperledger that I will discuss in my later talk. The smart contract will help you exchange the money, property, shares, or anything of value you can build a smart contract. So if I'll talk about the supply chain that we are doing right now, so you can build a smart contract for tendering, for auctioning, for purchase order generation, or even you can build a smart contract for the verification of the goods, and all those things can be implemented on a smart contract. And the real-time problem that we are facing, so if you are going for a supply chain, as like most of the people are from the same background, from the finances, or they understand about the supply chain. So there will be a vendor, there will be sub-vendor, and there will be level 3 or level 4 vendors also into the network. So level 3, level 4 vendors they are not very much educated in terms of this new technology. So how we are going to interact with them? So for that, we can create like a certain system, like not a control by, but the running node will be somewhere, like the experts are there. But you can build a certain interface, like right now we have a normal banking system, you can say. The normal banking system, people, like everyone is using, almost everyone in India. Okay. So you can build a simple interface for them. They just have to log in on their account and they can just upload the scan copy or like the thing you want to trace. They can just upload on that interface, and you can put that on you can make that contract and you can put that on top of Ethereum or Hyperledger on a blockchain. So that will be kind of very helpful for those people also. If they are not literate, also the digitally literate, then also they can participate into this one, the smart contract traceability. So the smart contract, as I discussed about the details, so I'm not going to cover this one. Yeah. So the smart contract, it is kind of self-executing contract which contains a certain terms and conditions of an agreement between peers. So if the terms and condition of an agreement is written in the code, and when these agreements facilitate the exchange of money, shares, and property, etc., then this will happen, and then it will execute it on a blockchain decentralized platform. So if I talk about in a simple term, so if you want to, suppose there are almost 5 people into the network, and in that 2 of them, they want to exchange some property or exchange something. Okay. So they will write a contract, a computer will write a contract, and if both people are like, if they will satisfy, there are certain conditions. Once that condition will be met, then that contract will get executed automatically. You don't have to do it manually. So like we have right now, once contract will be built, people will make, people will sign, and it will take some time also. But in terms of a smart contract, it will not take more than few minutes. So it will get executed when the conditions are met. So in the normal contract, so people, like the transfer of ownership will happen on a paper. And this paper, like we also know, this paper can be tampered at any point of time. If people are more powerful, then they can go on a backdate also, they can change the contracts. But in terms of a smart contract, there are certain conditions you cannot tamper, because once a contract is written and once it is deployed on a blockchain technology, then you cannot change the data that is written into the contract. You can write another contract and you can forget those contracts that is written before, but that contract will still be online. If you want to see the old contracts, you can go into the network and you can check that contract. And the new contract you can write and you can deploy again on the network. So why we are using a smart contract? So for that, we don't have any, in terms of traditional contract, we have a third party, but in terms of a smart contract, we don't have any third party. So it will eliminate the third party. That means it will eliminate the time that is getting consumed in that process to do those things. And also it will reduce the cost also. And the cost is kind of conflicting, because the contract, the smart contract, if you are running on a blockchain, it will also cost too much. But I am sure it will not cost that much that is into the traditional contract. Okay. The execution time, it is almost like, it depends on the certain, it depends on the offices or the people is involved into that traditional contract, but almost 1 to 3 days we can say it's average time. But in a smart contract, it will take a minute. The remittance is manually in traditional contract, but in a smart contract, it will happen automatically. The transparency, there is no transparency in the traditional contract, but in a smart contract, it is available 24/7, like cross 30, cross 365. You can check anytime and anywhere. The achieving is very difficult in terms of traditional contract, but in a smart contract, it is very easy. And the security is, it is also kind of conflicting. The security in traditional contract is limited, or we can say it is also depends on the application, but yeah, we can say it is very limited. But in terms of smart contract, you can make it cryptographically secure, but once you are making it secure, make sure to use a technology that is relevant for your application, or like that is relevant for, like that is suitable actually. You can say like, if you need all those, I discussed like permission blockchain or the private blockchain, all those things, if those conditions are met, then you can use this contract. And what type of contract is implemented and where you can deploy those contracts. The cost is expensive and the smart contract is cheap, and the signature is manual process, and here it is digital signature will be used in smart contract. So the overall difference, if I'll talk about, then it is, there are human involvements in the traditional contract, but there is no human involvement in the smart contract. If you will write a computer code, it will get automatically, everything will happen. And these are the, you can say the advantages that, yeah, these are the, some are advantages, some of the disadvantages I'll discuss in separate. Okay, but these are the properties that a smart contract hold for what we are doing right now. So this is smart contract. These are not free to use. If you want to make a tamper-proof, and if you want to make it like the traceable and irreversible, then you will have to implement, you will have to deploy those smart contract on certain platform. Those platform are like the blockchain platform, we can say. Blockchain platform means it is not related just to blockchain. Blockchain means, a platform means blockchain or Ethereum or Hyperledger, or like we have a lot of other blockchain platform where you can deploy those contracts. So this will share you PPT, I think. So the gas will require to run a smart contract. Gas is kind of, you can say, the smart contract running on Ethereum, they have their own currency called Ether. And this, the gas fees will be there to run, and the cost in Ether, it will come, you can see it is like 0.00000009. So it is kind of very small fees that they will cost to run a contract. But yeah, it depends on how lengthy contract you are writing. It depends on the coding that you are using. So this cost depends on those things also. And you can add or subtract to integer in 1 million time, like the cost, the gas will require this much, and the cost will come 0.09 Ethereum. It is little bit much, like it depends on like how much coding you are doing into the contract. Those, the fees will, is directly proportional to that. So now I'll talk about some applications, a real-time application that people are using. So first one is for a digital identity. So you can access if you have written this contract is not just between the two people. Like it can be between a group of people or with the government also. You can like government also can make for the digital identity means we have right now we have Aadhaar card, so they can use those contract into that thing also. So they will access your identity and they can play a vital part in safekeeping all those your sensitive information. And you can see on a blockchain where is your Aadhaar card is getting used. Right now, I think they have some platform where you can see, but not all the things you can see where your Aadhaar card is getting used. So with the smart contract, it is possible to allow third parties to access certain part of your identification without fully revealing all of those information that is on your identity. So this will also allow a third party to validate your information, whether it is correct or not, but you still remain full control over your identification. That means if you are sharing through the blockchain, then obviously this is getting verified before putting onto the contract, and then you can check, the third party also can check whether all the information are correct or not, where whatever you wanted to share if you have shared those things. The securities. So with the smart contract, managing securities can improved and simplified. As I said, like a normal contract can be changed and altered, but yeah, in terms of a smart contract, this is practically impossible. So usually there are intermediaries involved in security custody chain, but therefore there is always a vulnerability involved in terms of contract because you are going to implement those contracts on some platform. That platform may be vulnerable. Okay, but a smart contract can reduce the operation risk of securities and make the workflow more digitalized. And user can also use it for automatic payments, like for the dividends also, stock splits, and even for the liabilities management. So the cross-border payment also, right now we face a lot of difficulty when we are moving to the outside of country, then there will be some cross-border payment issue. So right now we have something, but not that much efficiently people are using that. So right now, making cross-border payments can be more simplified using a smart contract. So mainly in tokenization of asset, where the owner can define the attribute of the asset and then send that asset to the other party. So what does this mean? So you can, right now we have a CBDC. People are like, as sir said, if you are building more secure and more advanced, we can say, then a lot of other countries also going to use that CBDC. In that CBDC, if there is a digital rupees, right now also we have on UPI, you can say it is digital, but the digital rupees is a little bit different. You cannot take out those money, okay? And all the things will be transparent, and once, like anytime, anyone, like not anyone, but yeah, the control authority, they can see all your transaction and they can keep the ledger with them and they can check all those things. And if you are going outside of the country, and if that country have adopted your currency, then obviously, like you don't have to get exchange anything. You just go there and you can pay in your currency, and it will be validated through that. And also the cross-border payment, it needs to adhere so many laws, so like which can restrict businesses, but with a smart contract. So partner residing in different countries can work together without any financial issue. So they don't have to pay any extra fees for the cross-border payments. So they can easily do from their like the application interface. So for the loans also, a smart contract can help. Right now we have a lot of, like if people are taking loan, a lot of hidden charges are there, and they are like charging anything like that. If you are like if you are bouncing the payment and other things, if you are doing anything, then they like there are a lot of hidden charges. But in the smart contract application, you can control those things, and you can see exactly where the charges is going clearly, and you can raise the question also if there is something there is any problem into that. So this will also track the condition, and it will follow the rules based on the outcome of the borrower. So you can see the contract before getting the loan. You can see that computer code, and you can check whether you want to take or not. So the another application is financial data recording. So this is also same. The property will be the traceability, immutability, and the irreversibility. The financial data is like, it is not some other data. It's for a computer, it's just data. So, but for our application, So it will allow, it's possible to collect data uniformly throughout a company business, and it will process without needing any regular auditing. So whatever you have written, once that condition will be met, then only you can see those data, or like the computer code, whatever you have written, this will work according to that. So in a government, like how you can use the smart contract. So as a smart contract have automated features, so it can help the government to run operation without interference from the third parties. And operations such as recording lands title can be done more efficiently and faster. So I think there are certain applications built on a land registry system, and few governments they have adopted also. So those land registry are happening through the smart contract. So you don't need any third party. Like right now you'll have to pay almost 8% or 9% of the total value in a land registry. But if you are going through the smart contract, I think that can be reduced very drastically, and it can be made more secure and more tamper-proof, you can say. So also it is kind of public record, so there is no option for anyone to alter as they want. So another possible use case is electronic election, so where the smart contract can count the votes and automated the whole process. So once, like right now also we have, but sometimes people raise question for that. But if you are writing on a blockchain, then there will be no control on a single of a single person. So like we have ED right now, but you can say like the node, anyone can participate in India. We have almost millions of nodes, you can say. And if 51%, more than 51% are corrupted into that, then obviously they can change. But yeah, practically you can contact to the other governments also, other country government also, and you can make them participate. So practically it will be impossible to alter those voting system. So in a supply chain, so this is smart contract, how the smart contract can improve those things. So this smart contract can improve supply chain management greatly. Like if companies are integrated smart contract in all part of the supply chain process, it can help track items to record data in real time. So this will only happen as I said earlier. So digital illiteracy, we have a lot of digital illiteracy in India. So we'll have to make very, very much simple application interface for the people to use it in real time. So it can also manage the inventories, and it will help process all the transaction and payments throughout the supply chain faster. So right now, if there are a lot of payment delays, someone is requesting for a payment, it will take almost 10 days or 15 days to get the approval of those things. But if you write the contract, on a contract, everything very clearly, and if the vendor and the supplier, like both are matching exactly, like they are meeting that conditions, then the transaction will happen automatically within a second. It will not take any time. So it can faster the process also. So in insurance also you can use. So right now, like by using the blockchain technology, smart contract can verify all the documentation and data and process the insurance claim if it falls within the condition. So the contract means like the certain conditions, once it will hold that condition, then obviously it will get automatically it will happen. And everything will be stored on immutable ledger. So the advantage will be the autonomy. No need for trusted third party, and the trust data is stored in shared ledger. So you cannot say, you cannot, if you don't have any trust also, so there is no problem for that. So we have contract is deployed on a blockchain platform, and the people, they don't trust anyone but the computer code. So that is very reliable because you are writing that computer code and you have created the conditions, but it cannot be, after that it cannot be changed. So you can trust all those computer codes, the one you have written for yourself. And the data duplication will be there. Suppose you are into the network. So this question I get a lot, like in a blockchain, suppose or in a smart contract, suppose there are 10 people into the network and everyone is connected. And what will happen if someone account get deleted from that? Okay, will they lost all the data? No, they will never lost the data. Once they will come from another computer, once they will join into the network, once they will log in onto their system, all the data will get copied on another system also again. So you can have all the copies of the ledger at every time with yourself, and you can verify all those data at any time. So it will also automate the various processes, so that will increase the speed of contract. The challenges, there are certain challenges into the smart contract also. So first one is the scalability problem. So that is the scalability problem in all the blockchain based applications. So the interoperability is the biggest issue, because all the things you cannot make on a smart contract. There are certain things that you will have to use the database. And that this interoperability is the biggest issue that I'm also facing right now. And this is kind of, if you are going totally on a blockchain, then this issue will not come. But yeah, we cannot build every application on a blockchain. There are certain things that we need to build on a blockchain, and that interoperability is the biggest issue right now. And obviously the regulatory challenges are there. So a lot of people, if you will talk about the blockchain, they get afraid about the blockchain. Okay, but there are certain incident also happened, but it's not blockchain's fault. It's people's fault, the people who are using that blockchain. Okay, so if you will not be careful, then your money will get lost. If you are not careful, obviously something like FTX will happen again. So it's not, you can say it's not a problem of a blockchain, it's problem of those companies and those peoples. So you can trust blockchain, I will say, and you can use those applications. Not all the blockchain, I will say, but yeah, certain properties of blockchain you can use into the applications. So the governance problem we have, because we don't have any legal things for a blockchain in India right now. So you can use it in anywhere, but people are using, but not all the blockchains. Not Bitcoin, people are not using for a transactions. Like people can use their, they can make their own token and they can do the transaction. But yeah, once we'll have a CBDC, then it will get, it will be very easy to use the blockchain in India. And then other proposal, we are talking about a lot of people for this one. So if we are building our own blockchain like we have in China they have BSN network. So all the Chinese applications, they are building on that BSN network. So in India, if we have our own blockchain network, and if we have our own digital currency on top of that Indian blockchain network, then it will be easy to do all these applications on that platform. So we don't have to pay fees. We can rely on our blockchain technology, and it will help in a lot of ways. So the other problem is digital literacy. That can be solved, but yeah, but it will take some time in India to implement all those things on a level 2 or level 3 or level 4 people. So that's for my time, and thank you so much for listening me. So any question? Yeah.
Thank you, Amit. So I have a simple question. Do I necessarily need a blockchain for smart contracts?
It's specifically not, I will say, blockchain, but yeah, the smart contract is a contract, right? A contract, a piece of code. But you will have to deploy it somewhere.
Correct.
Right. So you need certain application of blockchain to deploy those contracts.
So we need blockchain for the smart contracts?
Blockchain means the understand.
Some piece of code is required, but not necessarily blockchain.
Yeah, not necessarily blockchain, yeah.
Right. So the challenge with writing the code, especially in blockchain, is that, see, in blockchain there are two parts. One is writing the code, another is deploying the network itself.
Yeah.
Both are challenging. But network needs to be secure, and it needs to scale up. And writing the code itself is a complex piece. As you correctly pointed out, that the literacy in that field is not there.
But writing code is expert's work. It's not like you are going to make them write who are level 2 or level 3 vendors into the supply chain, if I'll talk about the specific application.
Correct.
You are just, suppose I am working for a Chris, okay. So you are sitting in a computer room, like in a Chris center. People are like computer experts, okay. So they are IT experts. They will write the code and they will make a simple interface for the level 2 or level 3 vendors. So right now they are logging into their system and they are feeding those values. So same thing they can do right now also. You can write the contract and you can deploy that on a blockchain, and you can run all those things from by sitting into that room, okay. So the one you are doing right now. And You can show them, so this is the contract, and once you will match, your payment will automatically get done once your work is done, and it will not take any time for payment, and they will also get motivated for those things, but you will have to make it simpler for them.
Yeah, so basically then what we are suggesting is that the contracts in the business form needs to be explained to some kind of developer who will convert into code and then later on it will get executed.
So right now, I'll talk about the specific purchase order generation. Okay, so purchase order means there are certain, like on a paper you will write something, the value of those things and all those digital signature, everything you will write on those papers, right? So those things you can write on a code, and you can put a digital signature on top of that. And these things, what happen, that is kind of a manual process. Okay, you will go and you will check all those things. You can write the conditions there also, okay, but that is stored at a single place, okay, that is centralized data. So you can tamper with that data at any time if you have that authority, okay. But if you are writing on a contract and if you are deploying on a network, you cannot put it on open network. You can create your own network, your own blockchain, okay. Suppose into the railway, they build their own blockchain network at a CRIS, and all those 29, 28 nodes and the other vendors also, they can add into that network. So all people can see how much transaction is happening and when happened and how much they delivered, everyone can see. And that contract will be very transparent, and you can show that contract. It is open and you can show all the vendors, and once they will agree on that, then this is kind of like the work is kind of like in a second it will happen. The contract will get executed.
Right.
Yeah.
So you mentioned about scalability.
Yeah.
So one of the challenges of the blockchain is scalability.
Yeah.
Because as the data increases, the effort, which is the processing power as well as the cost to get the data out, increases heavily, right? Is there any study to show that or to determine the cost of that?
So there are studies, but I cannot show those studies because I haven't prepared for that. But yeah, I will talk about that. So right now we have almost 500 GB data in a Bitcoin. 500, almost 500. I don't know exactly, but yeah, almost 500 GB data in a Bitcoin. If you are going to deploy that network in your computer, then you will have to download all 500 GB data on your network, okay, on computer. So these 500 GB, in a 72 lakh transaction, 72 lakhs block, multiply with 2000. That average is 2000 transaction in single block, okay. So if you multiply those things, and it will come, I don't know, in few millions, I think it will come, okay. So that data is 500 GB, okay. And if you are building so much transaction in 500 GB, I think for a government organization, they have like very large data, not 500 GB, they have in TB or petabytes, like they have data, right? So this is kind of reducing the data also. It is not increasing that data, I will say. Yeah. Yes, sir.
Thank you. See, I need to buy a product. For that purpose, I upload my tender on, say, platform like Gem. So if I now, since seeing the smart contract, I feel that, okay, I should go on a smart contract. So what I have to do, like, means to get into a smart contract with my vendors?
Okay. So what I am working right now for a railway, I think your problem is same you are saying, how to implement that smart contract into the system, right?
Yeah.
So first, like we are working on a purchase order. So how to create a purchase order?
No, first, I need to float a tender. So
Yeah.
I have a platform like Gem on which I can float a tender.
Yeah.
Thereafter, vendors will
So you
respond.
can have same interface also. Like you have right now, you don't have to face anything. Like the people who are creating the tender, who are placing the tender, they don't have to. There will not be any change for them. Change will be for you people who are who are on the backend team. Okay, they will have to create the network. They will have to create a user interface for them. You can make a same interface, the one you are using right now, and they will just log in into that system, and you will get those data, and those transactions will get fastly, and those contract will get executed automatically. It will be for you, not for them. For them it will be very easy, and for you also it will be very easy. So like the data cannot be tempered. For them also it is very easy. For you also it will be very easy.
No, but for uploading my tender, now on GEM it is very easy for me to upload a tender. Now, but then there is no provision for smart contract to get into a smart contract, because that can be entered only on a, preferably on a blockchain.
Yeah.
So how do we go about it?
You don't have to put it on a blockchain. If you are, suppose if you are a supplier, okay,
Yeah.
you are, and I have proposed a tender for you, and you are putting those entries, okay. Right now what you are doing, you are just logging into the system, you are putting all the information, okay. This is your company and these are all the bits that you are placing. The same thing you can do here also, and that PDF get generated, right? The tender PDF get generated. So the same thing also you can generate, but the contract will not be it will not be stored like a PDF that we have right now. It will be stored on a blockchain. It will not be stored on a system, the one you have, a physical system right now, or like in the centralized database, I will say. It will not get stored there. It will get stored in a decentralized platform, the one you are using. Like right now, I am using Hyperledger Fabric. So it is kind of permission blockchain. So you will have permission, and you can give those permission to certain people who are into the authority, like who is on a few, like 20, 30 people you can give. And if all those people, if you want to change those contract, all those 20, 30 people will require for that. You can write all the codes for that only.
But how do I get on that blockchain platform? What I have to do to get on that blockchain?
As a supplier, or as a...
both as a buyer as well as a supplier. Even for my
Amit.
vendor, how they will get on the blockchain platform? What is the procedure, or what is the way to get on that?
So you are talking in terms of customer, or you are talking in terms of...
Even for a like buyer also, if I want to upload my tender on a blockchain platform, how do I go on that platform?
You will not upload a tender on a blockchain platform. You will upload a tender just like you are doing right now.
Say, for example, right now I am uploading on GEM, but GEM does not have a blockchain platform. First, they have to create a blockchain platform.
First the GEM have to create a blockchain platform. They will have to create an interface for them. Right now, the GEM have, okay, the people who like where they are uploading right now, you will have to create a same platform, like same interface for the user, and they will upload their data on the same, like they are doing right now. The same, they will upload their data on that platform, and then it will come to you, and it will get on a blockchain. Then you can see those whatever people they have uploaded, and those people also can see at any time what they have uploaded on a blockchain.
Okay, now I have a choice to go on GEM. Suppose if I don't want to go on GEM, I want to go on any of available blockchain platform. Is there any such platforms available in India, like where I can...
Fabric we are using right now, Hyperledger Fabric.
Hyperledger Fabric,
Yeah.
okay.
That is kind of permission blockchain. Yeah.
So, but is there any registration required to get on to that platform?
If you are putting a contract onto that, then you will have to pay the fees. Registration is not required. Yeah, if it is a permission blockchain, you can write your identity also, or you can become anonymous into that network. But if you want to, like, why Bitcoin was there, like for the anonymity of people were misusing those technologies. Okay, so that's why it came this permission blockchain. Here you can see all those people, they can write there. You can, whatever data you are taking right now, the same data you can take on a blockchain, but the certain these properties the blockchain will hold, this will be benefit for you.
Okay. Thank you.
Thanks a lot. We can have only one question now.
Yeah. Okay.
See, please understand that whatever we are doing in the domain of supply chain in India, they are all based on relational database. Okay? As he was asking, if you have to shift to what is here being discussed as a smart contract, that architecture first of all has to be developed. And just as in the case of relational database, whether it is e-procurement or entire end-to-end supply chain, a concept developed which took about 10 years to come to this stage. Here also, the concept will develop, and as somebody was asking whether it will be, we need a blockchain, and he answered yes or no. There can be a situation. Now, those of you who are in the domain of supply chain, if you want to use smart contract in the context of public procurement, blockchain will perhaps not be used. This is the current level of understanding. Whether you call it GEM or PPP or IREPS, none of them are currently geared for a smart contract. The first step which has to be done for a smart contract is to tell the supplier, here is your contract. And this contract is as much yours as it is mine. You don't have to log on to CPP today and tomorrow to NTPC and third day on GEM. You be on your platform to the extent either NTPC or GEM or CPP is also on some kind of smart chain. You can log on to your system. You take out only such data from your system which you want to share with a particular party, say GEM, and GEM will get data. So conceptually it is different. There is no master holder of data like GEM. Operationally, it is different, and coding-wise, it is different. There was a question whether every contract will be coded. No. Every type of contract in your language, if it's a global tender, if it's advertised tender, if it's a rate contract or kind of thing, you can have smart contract templates in which you can feed, just like general conditions of contract. And you can have special conditions of contract, which Professor Shyam Sundar was talking about. There can be a human oracle or human body who knows कि ये global tender है, इसमें bill of entry लगेगा, so something else has to be done, and for which maybe coding is too complex. So he will do that manual thing. Is that clear on an operational level? Okay, now we don't have time, and the next lecture.
Sir, I mean to say, the part of the smart contract is already under implementation in GEM, because GEM, the push button procurement is there.
No, hang on.
Where we give just our requirement and we get the contract
exactly.
in 5 days.
So it is basically matching database to database.
Yeah.
That is what GEM is currently doing.
Yeah.
And therefore it is relational database based.
No, it is doing the evaluation, and finally we just give the requirement, and within 5 days we have to only sign the contract. We don't have to do anything.
But it is centralized with GEM. Okay, fine. If you want to call it smart contract, live with it. No problem. Fine. Okay. आप कृपया क्षमा करें क्योंकि अब समय नहीं है. We have our next speaker from Bombay. He is the director of NITI and he is waiting. So please get on to that.
So our next lecture will be online, which will be given by Dr. Manoj Kumar Tiwari, as he couldn't join us due to some personal reasons. Professor Manoj Kumar Tiwari is the director of NITI Mumbai. He is a fellow of Institute of Industrial Engineering, a fellow of Indian National Academy of Engineering, a fellow of National Academy of Science, and a member, Board of Governor of National Institute of Advanced Manufacturing, Ranchi. He is the first person from any institution in India to have been awarded the prestigious David Baker Award in 2023 as an eminent researcher in the field of industrial engineering. He is serving as associate editors of IE System, Man and Cybernetics System, International Journal of Production Research, and many more. So let's hear it from Dr. Manoj Kumar Tiwari virtually. Before that, I would request Dr. Madhuranjan Kumar to come onto the stage and hand over the memento to Dr. Amit Kumar Vishwakarma.
Hello. Hello.
यहाँ से फोन करते हैं ये मीडियो कहाँ से है ऑडियो
Hello.
Hello, can you hear me?
Yeah.
मुझे सुना दे रहा है?
Yes, yes, sir.
Thank you. Thank you. Hello.
Hello, sir. You are on. You are live, sir. You can start now.
Thank you, sir. Thank you very much. Swami ji, my slide is visible? Amit ji,
Yes, sir.
हम बीच बीच में आपसे पूछते रहेंगे कि whether you are I'm audible or not, तो आप थोड़ा हाथ बताते रहिएगा, ठीक है?
Yes, sir.
Thank you. So, first of all, I place my profound regards to Dr. Madhuranjan ji, who is spearheading a very interesting project and doing wonderful work with respect to bringing all the modern decision-making tools in ensuring the automation as well as bringing smartness in the public procurement and some content of the supply chain. I met a few of his juniors and colleagues who have been involved in the public procurement of large goods and services, particularly in the railway, and they all hails and appreciate the effort which he has poured to promote this particular segment of the supply chain, particularly procurement and the different kind of contracts, which are very much difficult to understand many times because of the complex nature of the points which are there in the contracts. And we all know that when you want to sign a contract, then contract depends on many type of things, like say what is the reputation of the firm, the type of items, its specification, weight and size and volume, and how the transportation is to be done, how we can go ahead with the delivery of the items. There are many kind of things which are there involved in this. Particularly, this assumes a specific significance after the advent of and proliferation of the distributed manufacturing, which is there that most of the top firms and bigger firms, they are having the different subsidiaries and they have different components are manufactured at different places by different organizations. So keeping all those factors in mind, it is essential that we have to bring some sort of intelligent automation in the domain of public procurement. So it is noticed that in recent years, a particular tool called artificial intelligence, where the machine learning is one of the important component of the data science, through which data need to be analyzed in different ways, classification, codification, and clustering, and then using the different smart tools, whether they are stat-based or they are machine learning-based. They are primarily used to find out some useful information and patterns through which some sort of prediction, and later on through the OR tools we can do the optimization. So a particular term which became very popular in recent days is called the smart prediction and optimization. When I use this word smart prediction and optimization, here I used to refer that the prediction is to be done through some of the tools of the machine learning, data science, and then based on the outcome that we received along with the other component, then we go for optimizing the problem, and then therefore what is the decision error that we want to minimize. So keeping this particular development in mind, this idea of smart contract in public procurement assumes a specific significance. So let us move ahead with the rest of the presentation after setting the tone for this. So I am going to cover some aspects of what is the smart contract, then benefits and its applications, and how the AI and AI smart contracts look like, and then AI-driven smart contract process, and how it is there in the AI procurement, and various specific terms which are recently being coined with procurement. It's called chatbot, how it is interpreted, and then automation and smartness. And of course, anomaly detection is a big problem in any area. So here also, how AI is going to use to find out the anomaly detection. And then there are some case studies which we know. And recently also one of the very popular case studies which has been reported from the Harvard Business Review, that is improving the shipping contract with the use of blockchains, etc. So they are also there. So I am going to confine my talk with respect to this. So as you can see that there are, say we want to define two types of contracts. One we say that traditional contracts, and then say smart contracts. The main difference you can find between the traditional contracts and smart contracts are, say first of all, how much time it takes to sign the contracts. So traditional 1 to 3 days, say, and here it takes only few minutes to few hours. And remittance, in the traditional contract it is manual, and here it is automatic remittance of the money can be found. And traditional contract, because of many manual involvement where labor is involved, process is lengthy, so expensive, whereas smart contracts are quite cost effective now. Here physical presence is very much essential for the parties to sign the traditional contract, and keeping in mind that many recent web-based distance, AI or AR/VR technology, now the virtual presence would be significant. And intermediary is essential in the traditional context, whereas because of the everything is available with respect to the videos, audios, and everything, so no need of intermediary is required in this one. So keeping the main difference in mind between the traditional contract and the smart contract. So here we would like to highlight some of the points like contracts that are self-executing with terms of the agreement between the two or more parties. They may be referred to the smart contract. Then these are the contracts which are not depending on the intermediaries for the execution. And we also found that one of the very powerful technology which is based on the recording at the laser basis, and where many places in the indelible kind of recording which you cannot delete actually. So that is also there's a blockchain technology. And I just referred a contract now where particularly between the hiring of the ships, correct? That is called a contract between the charterer and ship owner has been signed, where they have demonstrated very nicely that how the consortium-led approach for setting up the standards and protocols that can lead to the faster adoption of the blockchain-based solutions. So blockchain, basically distributed ledger technology that stores the data at assigned nodes, and of course giving access only to the parties which has been verified earlier by the system. As you can see, some of the one of key benefits which one can realize by the smart contracts. You can see, first of all, there will be speed in completing the process of signing the contract. It is more accurate because there is a less chances of the error. Then transparency fully is there, that one can see that what is happening. Of course, security is a measure, which is a big challenge also, and somewhat insured also, but cyber attacks particularly, that need to be taken care in, in many aspects, like some malware or some complete program or complete system can be blocked or can be made non-functional. So security is one thing, but many layers of the security has been made, so therefore some safety measures are now being realized by the people. And here communication, of course, is quite fast, as well as at many layers, it can go in a few seconds. And basically whole process is paperless, so you can say sustainable. And there is hardly any CO2 emission is involved in the smart contract. And it is to be done very efficiently also, where the time required and also you can say presence or movement is almost minimal. So therefore, it is most preferred. And then trustworthiness is installed because at every stage there is a record and hardly there is any way to doubt on the processing. And then of course it ensures in the savings of the money, because at many places where travel, keeping the record in a physical form, as well as many other formalities that are to be automated. So in that process there will be saving also, and whole things can be stored and recorded for many years. So these are the some of the prominent benefits of the smart contracts, and that is why sooner or later most of the things can go in this way in days to come. Then some of the uses of the smart contracts where we can show and find out, like say when we say which area has more chances of its application. So we found that, so whenever you give an order, like say how to trace the quality, price, as well as all the transactions along the supply chain, and then the point of uses where there can be scope for the smart contracts. So you can say, like say, right from the ordering of the raw material, transportation, warehouse and port, and then it comes to the further transportation from the another port, and from that port it goes to the warehouse, again transportation, then particular shop, and then fast selling. So you can say at many places, like in this way ordering, there will be contract, port, between port and ships there will be contract, between the port and warehouse there will be contract. So at every place you can see there are different forms of the contract that need to be signed by the different parties. So some of the challenges of the smart contracts has also been mentioned here, and I just want to highlight. So Amitji, I am audible? Amitji? Amitji?
Yes, we are audible.
Thank you, sir. Thank you, sir. Thank you. So some of the smart contract challenges which are there, like say, first of all, there is a technological challenges where the need of scalability, that is new technologies always are coming up. So how we have to scale the whole process and take it to the other dimensions also. Then there is a question of interoperability because many types of operating systems, many types of devices are there. Their configuration is different. Their software level is different. We like say somewhere it is Windows 10, 11, somewhere Windows 7. So in storage and others, just a very small example. But similarly, it can also be found whenever you are using chatbot, robots, etc. There can be a lot of differences between the protocols and standards actually. Then there is a legal challenges. So many of the rules, like say they say that no physical presence is essential, signing of the document in front of third party, or you can say that signature in the original form in presence of the persons are required. So there are many ways where still there are some challenges legally not yet enabled because of the process involved. So that need to be also rationalized actually. Then there are organizational challenges like how the governance of blockchains, that who will operate the blockchains, how it will be maintained, who are the regulator of this kind of process, and then you can say the technology is evolving and not yet fully democratized. So therefore, there is a lack of talent also that you cannot find very adequate person. And I think Dr. Madhuranjan himself has faced the heat that when he wanted to hire some of the data science experts, I think 2 times he has to advertise to get the person, even though he was giving very high salary also. Same process we are also facing, that adequate talent who can easily apply their different techniques and tools, particularly decision science tools, to see that there will be a discernible pattern and proper information from the knowledge discovery can be had from the databases. This need to be assured, and that is why we require, somewhat more smart peoples to carry out these jobs. And some of the common challenges, as we can see, the privacy and security, these are all the which are, most of the concerns for the organizations. What will happen if there is some hacking? What will happen if there are some sudden collapse of the system? What will happen if there is a, crashing of the systems? And as a second thing, that many of the smart contracts which has been designed for AXM may have to be changed. So therefore, we have to make it more flexible and reconfigurable than what it is there. And then, at present we can say that high cost of operations because more people we require which are paid more, and then slow turnaround time of the manual process, siloed approaches, and then loss of revenue due to unclaimed entitlements, and some of the regulatory enforcement due to non-compliance. So they are the reasons actually why we have to go for the smart contracts actually. In showing the smart contract, we have to very massively apply the tools of artificial intelligence. Here, the AI is basically machine displayed intelligence that simulates the human behavior or thinking and how the search is to be conducted, how reasoning is to be built up, how the patterns need to come out, how the prediction is to be done. So there are some well defined process, and also the data in the form of image, data in the form of table, data in the form of graphs. They all need to be converted into a format which the algorithm can easily understand. And then there is a very interesting, multi-layer technology where many of the neurons, many layers of the neurons, they are there, and where we have many kind of inputs from the different data sources. And because of that, when you have to have more and more interaction among the layers of the neurons, then accuracy of the decision will be very high, prediction will be very high. So in that case, you have more authentic, more dependable, less error-free, less error-prone results are available by using this kind of mechanism. So types of the AI models are trained with the vast volumes of data so that the model supervised learning and also in case of unsupervised learning, there should be a well-trained model so that the prediction error will be less. Then one of the key elements of AI is machine learning algorithms through which there are many discernible patterns are built up, and these patterns capture the way that how the particular data set is behaving for solving the given problems, and based on that we have to do the prediction as well as decision making. And many of the algorithms which are there, one of the greatest example is the recently we call that Chat GPT, and this Chat GPT is also working based on natural language processing and the search algorithms. So natural language processing is one thing which has been very much automated, the type of process that we use in the contracts. And another very interesting thing, robotic process automation, which has very much helpful actually to mimic the human actions and then reproduce the repetitive simple tasks, which are very difficult for human being to do without mistakes. But robotics automation process that will do very smartly without committing error in that process. So these are some of the tools, and I can say that how the whole process of a smart contract works in the different domains. So here we have a blockchain driven smart contract, and how whole mechanism in different domains can be there, that we want to show you. Say for example, if you can see here there are say law enforcement officers. So they get some sort of information, and these files which are there, legal or illegal files we can call it, then this is to be converted into instructions. So it can be illegal file, original file. And then this need to be decoded. And from here, whatever information we acquire, that is buyer's address and commodity ID that we provide to the document that is there. And then we compare here for the user database and blockchain. So, and then whatever becomes, that way, this is to be, decision to be taken for the offender who has violated the contracts or who has violated the provisions of the law, and that way the offender is to be punished. So this way the data, how it is to be transacted through the different stages has been demonstrated. And smart contract, you can see the area where you can find it, the medical research, financial services and insurance, supply chain management at different stages, automated payment systems, then mortgage transactions which are basically taking place in the land and other items, and then engagement contract between the different parties, the real estate, one of the classic use of the smart contract, and particularly employment contract between the persons as well as the employee, or many labor contractors and between the organizations, then creating smart contracts for many other applications. And also through blockchain, how can we show the different kind of transparency. Then comes AI-driven smart contract processes. So negotiation and agreement on terms of the contract between the all parties involved, that is very common phenomena. So negotiation itself has been mapped and captured through different steps. And there are many multi-agent based principles have been developed by the computer scientist community, through which the negotiations based on the multi-agent systems, how the involvement of the game theory was there, how evolutionary games can be used there. So negotiation becomes a very different area. So, but it is many times part of the agreement. So how the negotiation aspects can be inbuilt into the contract so that some of the process can be automated. And whatever the contract terms are encrypted in codes and stored in the blockchain, that need to properly represent the conditions that have been specified. And then evaluation of the contract to automate and execute the contract when eligible conditions are met. So contract can only be executed like what happens in the petri net. Whenever we have a place, we have a transitions, we have a tokens. So only execution of the whole process starts when there is a dot that is called token, available in the place, and it fires only when there are, rules says that, okay, this transaction can be made enable if there is a token number itna in the given place. So same sort of things can be executed in the case of the contract also. When the contract is to be executed, or green signal is to be given, so that mechanism is to be automated for execution. And then outcomes are recorded, that what is the outcome of particular execution process, as well as we have to update it at all nodes. When I say all the nodes, means different entities, different places, transitions which are involved in the process, they need to be updated. Then a term, very interesting term, which is there used in the case of the contract management, and different processes are there. So let's say contract management process details. What are there? The entire process, how it is to be represented. Say for example, if you can see here, the contract management process details involves different stages. Like say request for a new contract or the review of the existing contracts normally arises. Simple example I tell you, when you purchase most of the networking items, for computerization, automation, as well as for the providing internet connectivity to the institutions. So we go into agreement with the many of the supplier parties. Quite likely possible that you have some of the switches of the old configurations are there, some of the switches you require for new configuration. Many times even the like fiber optics cable configuration also gets changed. So 10 years ago, what was now what is the configuration? Then question is, in this case, suppose you have signed 4 years before back also, then there are many cyber security kind of firewalls and softwares which has come up. They need to be updated. So therefore, any contract, whether it is for the execution or procurement, there is always need to have a new contract or go for renewal of the review of the updation of the existing contract. Then comes authoring the contract, means what are the key terms and conditions, like when to start selling, total number, quantity, distance, mode of transportation, and then terms of the payments, value of the quantity, and like say, I recall in our days whenever we want to purchase some of the heavy machinery from the abroad, then we have to do the payment of all things through letter of credit. And we also mention in our contract that, okay, goods and services, goods to be supplied, then there was a term called FOB, free on board. So later on we come to know that free on board means the item will be delivered at the nearest port only. And then the security and insurance will be go at your cost actually. Whereas had they have taken CIF, that is right from the cost, insurance of the freight up to the delivery places, then this has been would have been borne by the party who are supplying the items. So quite likely possible we all were used to write FOB at that time, because most of the provisions were applied at that time for that only, and we were very mechanically using FOB. So now when we became slightly knowledgeable, then we found that CIF is more important than the FOB as far as ensuring the safe services of the goods that we procure from outside. Then negotiation and approval. Means if there are certain quantity and you take more quantity, less quantity, 10 pieces, 20 pieces, then what discount you are going to get, or even there can be some relaxation of the spare parts that we are going to have for a longer items, like when you go for engine or you go for aircraft or you go for some of the other machinery which are very special purpose. So in that case also in most of the things you need to have negotiation, how we are going to reduce the price, how we are going to have some sort of advantage in terms of the savings, as well as we get it some amount relaxed. So those are the things that are part of the negotiation. So we say that cost can be minimized, our total supply cost can be minimized by that process. So discount and penalties, they need to be discussed and negotiated. The contract performance analysis means how it is working, whether timely delivery is taking place or not. In defense and high machinery area, this is very, very important that we have to regularly monitor the contract performance, how many items promised have been delivered, what are the delay time, how it can be reduced, and the performance of the items coming is same or not, how many of them are get damaged, what are the shipping modes adopted, same shipper is to be used or different shipper need to be used. So this way, we have to analyze the contracts and then amendment and expiry, if it is there, that need to be renewed and also otherwise go for the signing of the new contract. Here, the objective is to eliminate the pain points in all the 5 steps that we mentioned. So to eliminate the pain points means the points where there can be some of the difficulties being arisen due to some nature of the contract process. How can we automate, say, price negotiation by a AI-based chatbot? So here we have to map the functioning of the AI-based chatbot. What is this chatbot AI-based? Means you have to give the information, then they have the inbuilt algorithm, and with the help of that algorithm, they give you the answer. So you have many if and then procedure also that you can put, and then corresponding conditions you may get. If this is the situation, then what will happen? So that kind of things can easily be solved by the AI-based chatbot. And then layout and activities and steps which are involved in negotiation process, particularly with the AI chatbots, is also mentioned here. Say, for example, we should have to collect the historical procurement data. Say, in last 5 years, last 4 years, last 10 years, how much procurement of the process, stock availability, delivery items, failure items, items which has gone out of become non-functional. So this data along with it need to be properly captured. And so many times for newer product, it is not possible to have the historical data. So in that case, what we have to do, we have to divide the, say, 7 month or 8 month or 1 year's performance of similar kind of product, and then first 6 to 7 months we use for training the data. Then remaining 4-5 months for testing data, and then we can go for the prediction. So like this, similar kind of process and nature of the product need to be searched when the historical data is not in a very large number. Then vendor KPIs means what are the things like fill rate, then how the date for delivery, how the availability of the items is ensured, defect, that 10 items got out of order or 5 items damaged. So all those things, they are the KPIs that we have to follow vendor side. And then getting vendor input, that is what are the performance scorecard, means out of say some number, you have ensured that okay, these are the points that we are giving you. Then recommended price using statistical or machine learning methods. So you have to use different kind of tools like linear regression, lasso, or many other boost, G-boost, or some other techniques to give the recommendations that with this process, what is the outcome, what is the prediction, how much error will be there, and then classification of the vendor into high, low, medium performance categories using the statistical methods or any kind of decision tree process or random forest or many other AI-based method. Then in AI and procurement, as you have seen when we described the previous things, you can find out that idea is to come out with better decisions and then find out the newer opportunities also with this process, and then improve the existing operations and some of the manual tasks which are boring and time consuming and repetitive tasks which are difficult to repeat the process accurately, they all can be done through the AI chatbot type of process. And AI can automate many time consuming tasks such as monthly processes and procurement, performance reporting, etc. Then we have the free up time by taking care of more routine tasks, and then we have to capture or apply the many scarce knowledge which are not able to be do by the manual and other, traditional process. And then we can also go for testing and checking. There's some hypothetically new suppliers that may come into picture. And of course, then optimize the supplier relationships. Samiji, I am audible? Amiji? Hello?
Yes, sir, I am here.
Thank you. So, there are many ways, particularly in which AI can be used for smart sourcing in the procurement process. The first automation which we have shown is the AI-powered bots. The second and more important is the AI-powered tools which are helping to collect the information rapidly, then represent the whole thing, then analyze the commodity, and also analyze the market, and then use the supply intelligence to find out the different market strategies for doing the procurement process. Then how actually some of the system works actually. So smart contract and chatbot processes, we have tried to capture it. So first of all, let's say we have a requirement of the product. Then we have to collect the suppliers and vendors bid data. So there are two databases, as you can see here, that online data search engine or bidding platform. And here the whole database is there. So there's the interaction between these two blocks. And then determination of the recommended price. And this is to be done by a hybrid chatbot, which is here. And then based on that, we have to find out the vendor performance. And then we have to go for the negotiated price and then either sign the contract or exit and then close the decision. This is the one form of this one. So how the decision board actually here, it works. So suppose here we say the recommended price is less than offered price. This particular, link or this particular branch of the decision board, suppose says the recommended price is less than offered price. And this branch of the decision board says that recommended price is greater than offered price. When the recommended price is greater than the offered price, certainly we go for the deal and complete it here. But when the recommended price is less than the offered price, then there is an element of the negotiation involved. So when negotiation price is less than the revised recommended price called RRP, then there can be three possibilities. What are these three possibilities? Suppose we say that this is correct, so we sign the deal. No, then we can reject it also. And third case is that in high performance category, the negotiated price can be less than equal to this revised recommended price multiplied by a factor called negotiating factor. So this negotiating factor depends on many circumstances, type of items and delivery, etc. So deal and request for some perks are rejected. So like this, how the decision board which has been shown here functions and how its inner algorithm is being coded, that it can be given here to any hint actually. So interface of the negotiating board actually. So as you can see that here, we take the, like say, first interaction. So input from the seller or starting note and messages will be there. And then, data processing and identifying the intent here. That is the data processing, data dictionary, bag of the words and responses. And then price input means comparing the recommended price, correct? So that is called digital input, that POS tagging as a cardinal digit and comparing with the recommended price. Then bargaining response through negotiation, that comparing the offered price and quoting the revised price actually. and then ending note on final decision. That is, we are closing the loop now. So these are the part of the algorithm which is being used for carrying out the negotiation between interveners with the board. And then some of the well-defined terms which I have explained earlier also, just want to refresh it, that without smart control, chatbot buyers receive the higher wholesale price quote than human buyers. In smartness, what happens? The chatbot buyers, when informing suppliers, they are selected by smart AI algorithms, receive a lower wholesale price quote than chatbot buyers without AI recommendations. Here, the human buyers, when informing suppliers, they are selected by smart AI algorithms and they receive a similar wholesale price quote as human buyers without AI recommendation. So idea is that what is the difference between this automation alone and smartness, and then automation and smartness. So when you combine both, then when informing suppliers, they are selected by the smart AI algorithms, chatbot, buyers receive a lower wholesale price quote than human buyers. And here chatbot buyers, when informing suppliers, they are selected by smart AI algorithms, receive a lower wholesale price quote than human buyers without the AI recommendations. So this is about the automation and smartness, which is being the three categories. So people will prefer to go for the third one. That is what is being tagged for the next generation systems. And here just want to show here effect of the automation and smartness. So you can see this is the this particular axis going to say automated. This is all smartness. So there are human buyer, correct? Then smart, here automated, and in this quadrant it is automated and smart. So you can say that in this quadrant you can see whenever note this plus and minus and equal to is there, suppose this way plus sign, minus sign here, this is equal sign. So plus sign minus represents higher, lower and similar price quotes respectively between say human buyer and here smart buyer. You can say between these two, let's say you can say, if this equal to shows that there is a similar price between the two entities, correct? So in this you can see very clearly no recommendation, then human recommendation like this block, this one human recommendation and AI recommendations. So this is the way how the buyers type and different kind of discounts are there in a particular data set that has been taking place. And then we have categorized that key, how the AI recommended things you can see it in case of chatbot, how it is high. In case of female buyers, it's say here somewhat low equity. And then in case of male and all type of data, its performance looks to be good actually. And then AI in the anomaly detection, which is very common in different kind of contract, that what are the different kind of anomalies, what are the lapses, lacunae, and we have some sort of algorithms through which we can detect it. So based on the many of the theory which were found in the diagnosis, prognosis kind of things that were very much popular in the maintenance, MROs and other operations. So now same detection principles have been somewhat copied and also improved with the help of newer AI algorithms to see that how anomaly means changing in the pattern, some sort of abrupt steps or some sort of signals or some sort of you can say like in the machines you have vibrations, you have a noise, or you have some sort of different kind of flow, different kind of other things you observe. So those points of the what you call random performances, they need to be tracked. And based on that, actually, we can say here there is an anomaly. So now question is that how this anomaly is detected by the AI. So there is, say, for example, banking industry, they have used many kind of algorithms to check that what are the different anomalies there with respect to the, payment system with respect to the frauds. So bank is area where many algorithms have been built up. And I know at least several of my students, they are working in fraud detection process in the banks. Then this is the CPG firms, computer, what you call, many of the products which are there like a CPG type. You can say like many of the firms like Procter and Gamble, or you can say HUL, they are all CPG firms. They basically used this kind of anomaly detection for demand planning to estimate the better forecast of the item, because they produce large number of items, very large quantity of things to cater the whole seasonal demands actually. Then you can say telecom industry also, they used this particular tool, anomaly detection, that how the geek minds help in Fortune 500 company to fix different issues in the network. Then healthcare industry, very much they are needing that type of medicine, and also there are new molecules which are coming up, how they will behave. So these are the different areas where anomaly detection is to take in place, and they are the part of many of the contracts that we have seen in the procurement also. So with this, you can see similar kind of things we found in the many of the fintech industries, because fintech now is a very integral part of the smart contract, because most of the payments are done through the online systems, and they have to play a big role. So therefore, we have also cited that how they can be used for cutting the cost of the budgets or building where they are reducing the prediction risk in the investment, providing the other kind of hedging against the some of the political risking, then fraud prevention, then managing the credit card kind of default risk, and then optimizing the customer journey. So that lead to what? Decreased cost of the whole process. It minimizes the risk. Here the fraud cases comes down to a new level, new low level, then personalized services, and many of the increased revenues has been reported, and there are certainly the increased employee satisfaction also. And some of the terms which are there basically like say firms which are using this kind of, they are also been given here. So this is the how the advanced analytics in fintech is used. So we just want to cite few case studies in this particular process, that how the Walmart brought up unprecedented transparency to their food supply chain with the hyperledger fabric, is a kind of blockchain, and they produce many of the items like mangoes, strawberries, also meat and poultry items, dairy items, and multi-ingredient products. Their main challenges was that how to tracing the source of foodborne diseases outbreak, and then completing the task in minimal time actually, and then marking and protecting those farms which were not affected by the outbreak actually. Then approach, they follow the Walmart through the smart contracts. They use blockchain decentralized food supply system ecosystem. The company has partnered with the IBM for developing the food traceability system through Hyperledger Fabric, and it was tested in two products. That is tracing the mango sold in the US Walmarts, and then tracing the pork sold in the China Walmart stores. Of course, the result they found that they can trace the origin of around 25 products from 5 different suppliers using systems powered by the blockchain supported by Hyperledger Fabric. And for the mango in US stores, the time needed to trace this, their provenance went from 7 days. The second one was the how the digitizing global trade with the Mars and IBM. Here more than 4 trillion goods are shipped each year. Then 80% of the goods consumed, they use daily are carried by the ocean shipping industry. And by reducing the barriers within the international supply chain, the global trade could increase nearly 15%, that is boosting the economy and creating jobs. The cost that required for trade documentation is estimated to be 1/5 of the actual physical transportation cost. So, like say here, the different entities, as mentioned, like authorities, here the consignees are there, some freight, other agents like transporters are there. So, exporter, authorities, they are there, forwarders, freight forwarders, authority and carriers. So, how the relationship between them, what kind of what you call number of arrows going particular to one and then going to different, that shows the level of interaction that need to be done actually to ensure that how many data point need to be recorded before we actually receive the items and get that item at the end of the people that who want this item. So the inconsistent flow of the information across the organization, that is one of the reason. These main challenges, that manual time-consuming paper-related processes, risk assessment that often lacks sufficient information, and of course administrative cost of handling the container shipment. So that is why nowadays a lot of work is going on, that how the container traceability and container tracking need to be done through the many geospatial technologies actually. The results of such kind of outcomes of the contracts, AI-based, AI-powered contracts, blockchain-powered contracts between the exporter, tracker, rail, forwarder, and consignees and carriers, many and different authorities which are there after digitization, then fast, secure access to the different entities among the supply chain partners, then verifiable and immutability of the digital documents means tampering cannot be possible because it is recorded at different places. Then trusted cross-organizational workflow, then better risk assessment with the lesser intervention, and far lower administrative expense that is recorded there, and also it eliminates the cost to move physical papers and are moving across the other international borders actually. So these are the some advantages that has been reported. So based on that, I can say that what I wanted to cover about the smart contracts as well as how the AI powered decision making can be found in the uh, contracts as well as procurements. This whatever we have wanted to show, we have shown it to you. And now, is there any question that I can answer? Please.
Thank you, Professor Manoj, sir. So we'll take a question if anyone have.
Yeah.
Yeah, thank you, sir. You explained about autonomous and smartness in contract, but I could not follow. Can you tell us what is the basic difference of autonomous and smart contracts?
So did you got the question?
No, I'm not. I'm coming with a lot of echo, so you can translate it then tell me.
Okay, sir, the question is, he's asking, so what is the difference between autonomous and the smart contract?
Actually, it's autonomous. Actually, I have shown the automation and smart contract, but
I could not follow that.
I think there is a lot of echo. So can I say?
Yes, sir, go ahead.
Because when I speak, a lot of echo is coming from your side. Correct. Anyway, let me answer. Actually, the difference between smart contract and autonomous system is not much. Because I have given the example of automation. So in automation, what happens, many of the decisions are, you can say, based on some fixed rule. Whereas the moment you say smart, so more and more AI-powered decisions are being taken. And that is also happening in the autonomous systems also. Means where decision making is mostly automated through the different, AI-powered and software algorithms. So when we say autonomous and are smart, more or less saying the same level of, application of the newer decision-making tools. So I think not much difference between them. But it is autonomous minded. I'm not saying automation. Automation is slightly one stage lower than the smart and autonomous.
Okay, sir. So we have another question, sir. So,
Yeah.
Thank you, Manoj sir, for your especially two case studies. I would like to ask one question that in the current public procurement scenarios where in current situation like PSUs and many central government department, state government departments are procuring. So which are the areas which you find that where we can implement the block technology at least at the initial level so that it can shape a good shape in next few years?
So the question is in procurement thing, in the public procurement, like government body. So how you can use how you can use this technology and at an initial level.
Yes, yes.
Yeah.
So what I feel, first and foremost, all the public bodies, that they have a large amount of data, which I told you. So these data need to be properly analyzed and they need to be processed to find out, say for example, in a year or in 2 years, what are the different type of procurements, what is their requirement. One can actually guess, actually, say for example, at least some level of the requirement of that items in coming years, particularly when we have a large repair and maintenance system. So how many spares, what are things you request, you can plan nicely that, okay, how many pieces we can keep for 3 months or 6 months or 8 months. So this can simply be done if you have all the previous data. So this can help actually in the better procurement planning process. And also we can see that past data, suppose you have the contract with particular shippers or different shippers, then how you have procured the items, what is their performance, how many times they have delayed the responses. So that analysis also can be done using this particular smart AI and machine learning tools. Similarly, when you go for the negotiation, then if you can put the previous levels of the prices and then what were the initial predicted prices and how much deviations have taken place. So based on that, some improvements or some escalation has taken place. So correspondingly, how much actually it should be there in the net line. Also, some that sort of predictions can be made. And then different kind of risky situations can easily be captured by making more if and then type of rules, which can help the decision maker to go ahead with the procurement of this public procurement items with more transparent and more faster manner, with less paperwork and properly available record in the form of the undeletable or blockchain components, where very few persons have authority to change. So I think that way it is going to be hugely benefit to the public procurement parties, and hope that in days to come this will be the order. So what Dr. Madhuranjan is doing at an IFM, that is going to lay down a process which will have a huge impact on the procurement of particularly larger items in situations like railway or in the airlines industry or in the machine tool industry. They will set a very new standards actually for this. A lot of savings can be reported if we can part-wise, type-wise, proper analysis can be done. They are going to have a very new insights about the overall cost and savings that can be reported. That's also my side.
Yes, sir. Okay, sir. So thank you so much, sir, for the very valuable information about the AI in a blockchain. So, so we'll take now lunch break.
Thank you very much. And I just want to place my utmost regard to the NIFM authorities for giving me this opportunity to come online, though it's my in problem that I should have come physically and be there with you. But due to some problem, I could not come. But I will certainly come someday and meet all of you there. Thank you very much.
Yeah, thank you so much, sir, for your time. Yeah. Okay, sir. So now we'll have lunch. So lunch is at breakfast section, like where we had a breakfast, there same place we'll have lunch also. And we'll meet again at 3 o'clock? 2:45. 2:45 we'll meet again.
Good afternoon, all. Welcome you back. Now, the next lecture will be given by Dr. Parvat Singh Anjana. Parvat Singh Anjana is a PhD in computer science from IIT Hyderabad and a postdoctoral researcher at the Parallel and Distributed Computing Research Lab, Department of Computer Science at IIT Hyderabad. His research interests broadly span parallel and distributed systems. He has primarily been focusing on blockchain technology to develop sound and scalable methodologies for building efficient transaction execution frameworks. So I request him to please come onto the stage and deliver his lecture.
अगर पॉइंटर यूज करना है तो पॉइंटर यूज करना है यहाँ तो यू हैव टू कनेक्ट हियर ओके because they don't have USB full screen view नहीं स्लाइड्स को दोबारा एक मिनट हो जाएगा स्लाइड शो इट विल इन व्यू स्लाइड्स स्लाइड्स में सर इट विल बी इन व्यू स्लाइड्स second last okay so mic is there working mic is on so hi everyone it's not working right is it working audience से बोल सकते हैं और लोग भी हाँ जी ठीक sufficient है थोड़ा कट रहा है So hello everyone. So I am Parvat Singh Anjana. I'm talking about parallel execution of smart contracts in blockchains. So before joining at Supra Oracle, I was a postdoc researcher at IIT Hyderabad. So this work was done during my PhD. So we worked on increasing the efficiency of the blockchain platform by employing the parallel execution of the smart contract transactions there. So you might already had a lot of background now in the blockchain technology, like what is the smart contract, how blockchain work. So I believe like a lot of the things, basics are clear now. So I will go a further one more level to discuss about what are the challenges and what are the difficulties in blockchain platform. Like you had heard about interoperability in the blockchain platform, scalability, security, and various other aspects. Dr. Shamsundar has covered a lot of things there in the morning. So before I go into more detail of this thing, I'm thinking of giving you a intuition of a smart contract, like how a contract looks like, what are the conditions and terms recorded there. So I will give a presentation of a simple solidity contract for the simple auction, where we will have one bidder, one commodity, and there will be a number of bidders bidding for that commodity, and at the end of the auction, the winner will be given that commodity, and the coin will be transferred to the beneficiary. So Yeah, let's first look at what will the outline for this talk. So I will briefly talk about the blockchain technology and the smart contract. Then I will talk about the bottleneck and challenges when we talk about like parallel execution of the transaction in the blockchain platform. There are two different techniques which I with my other collaborator have proposed. One is based on statistical analysis of transactions. Another one is runtime analysis of the transaction and execution. So if time permits, we will go into more detail of these techniques. Otherwise, I will conclude with the contract and challenges in execution. Yeah. So let's first look at what is the blockchain technology. Like from the definition wise, it's already clear, like it is a distributed decentralized ledger of records which store the information in the form of blocks, where each block is having pointer to the previous block in the form of hash. From the genesis to block 1 will have the hash of genesis block 2 will have the hash of block 1, and so they are linked with each other. Each block consists of set of transactions and various other parameters like nonce and all those things which Dr. Shyam Sundar have presented in the morning session. So these blocks are added to the chain by the miners in Bitcoin and Ethereum. They are called miners. Basically, they are block proposers. They collect transactions submitted by the client to the blockchain. They form a block. They keep those transactions into a block, execute them, and then broadcast that block based on the consensus protocol called like proof of work, proof of stake, and various other protocols are there. So in proof of work, they solve the mathematical puzzle, and the node which is solving the puzzle first propose its block to be added into the chain. So when a block is proposed, the validator validates that block by verifying all those transactions are correct or not, and state validation, all those things will be done, and then block will be added. So every peer or every node in the blockchain network will maintain the ledger with them. So if anyone want to make any change to the earlier block which was already part of the chain, they require a lot of energy or a lot of proof of work they have to solve from that block to till the current block. So it is kind of like immutable ledger which require a lot of energy from if you talk about proof of work consensus mechanism. There are different type of chains like Bitcoin, Ethereum, Hyperledger Fabric, and Sawtooth, permission and permissionless, consortium, and all those things we have discussed. I will focus on Ethereum blockchain. Let's first look at contract, like a smart contract. So like contract is a computer program or code which record the condition and parameters like state variables in the contract. And when a user invoke a transaction, so it basically call one of the function of that contract which will be considered as a transaction, and it will be executed in the by the node with the blockchain nodes. So this is like you can think of as a like in modern blockchain, contract is a interface between the user and the blockchain platform. So it is sitting between both of them. So it is an interface software layer between the client and the blockchain. So examples are like Ballot, Coin, Simple Auction, and there are many whatever application we develop that will be a contract. And we already have seen the benefit of this. So let's first look at how a contract looks like. So I hope my screen is visible. Let me zoom in so it will be visible to everyone. So here you can see a simple auction contract. I hope font is visible. Yeah, okay, cool. So this is simple auction contract written in Solidity programming language. The interface you are seeing here is a remix ID, which is used for developing the contract and deploying those contracts in Ethereum blockchain. It provides all the facility. Here you can see like this is the first page of the Solidity interface, remix interface. Here you can write your contract, and all those existing contract will be there. So if you want to try, you can go there and look at those contracts. This is one of the contract which I have with me. This is the compiler which auto-compile those codes. And to deploy, I already have deployed one contract. Let me delete it and oh, no one is it. It's not working. But the font will be very small, right? Yeah. That's what I hope now it's visible, right? Yeah. So let me delete this contract. So this is the contract, okay? This is the contract I was showing. And to deploy this contract, there are different virtual environments Solidity provide, like injected Web3 and Remix virtual machine, and there are different environments are available. So let's say this is the virtual environment. Here you can see different accounts. So anyone who want to be part of the blockchain, like as a user or as a validator, you have to have an account. So your account is kind of like in normal, like you have in banking system, you have your account to transact or to do anything with the banking account. Similarly, here also you need an account. So here some sample accounts are there, and to do any transaction on even on Ethereum, you need to have some fund in your account, like ethers. So here some artificial ethers are given, 100 ethers are there in those accounts. You can use any of this account. Let's say I'm using this account to deploy the contract. So this is auction contract. I will go through the contract later on, but just like let's look at how to deploy this contract. So I'm deploying this contract. It requires several parameters as an input. So I'm giving this 100. This 100 is auction end time. Like this is simple auction. So in how many seconds from the now, the current block, you want to end the auction. So it automatically terminates the auction after 100 seconds. And here is the beneficiary address. One of the address, let's say, I will take another address from here. This is a beneficiary who want to sell his let's say, property or something. So this auction is for that. Just for imagine like this is the case. So he put his property for the sale. So I'm putting this beneficiary address here. Yeah. And now I'm deploying this contract. So this contract will be deployed here. You can see the sign like it is successful, right mark is there. So here you can see low level details about transaction hash and who has initiated this transaction, the gas used, and all those low level details are there. But for just like to have a feel of like this is a contract which is deployed. So after deploying the contract, here you can see the user interface. So this contract has these functions. Okay, auction end is show the auction is over. Bid when someone want to bid for, let's say I'm selecting another user, this user, or he was the owner, I'm using some other user, and let's say he is bidding. He put some money, like I want to bid 12 rupees or something. So this is again bidded. If assume like he after bidding 12 rupees, he want to bid for 5 rupees or something. So he is trying to bid, but this transaction failed because he is bidding smaller than the higher bid already there. So you can think of like these conditions are there in the contract. That's why it was able to detect those things. Now let's say he want to bid more, he bidding 50 rupees or something. This is again successful. Now let's say there's another. Before going to show you another user, let's check who is the highest bidder now. So this address is the highest bidder for this current bid. Now let's say the other user, someone else, he is bidding more amount than the 50, is bidding 55. So this transaction is successful because bid is higher than the previous amount. Now you can check the bidder will change. So here you can remember 78 is the end address. DC, the new bidder, is the winner of this bid currently. So assume like now when bid is over, like who is the winner, you can check the auction time whether it is ended or not. And when auction ends, it's saying already ended or something. Yeah, auction is already ended. Yeah. So yeah, this is like how you can see like let's go through the contract first, so you will understand what are the conditions there which is making this thing happen. So here the beneficiary, which address we have provided with the while deploying the contract. This is the auction end time which we have provided as input. There is the highest bidder and highest bid. The person who is bidding will be the highest bidder and the amount he is bidding for. So these two state variable recording those things. So whenever a transaction is initiated and it is going successfully through the system, it will be recorded into the blockchain. Okay. So this, because these parameters are changing, he is bidding highest bid, so parameter changes, the transaction is accepted, meaning that there is a block which consists that transaction is accepted into the blockchain and recorded into the blockchain. These are the other parameters which is recording like pending returns. So someone has bidded earlier, his amount was less, so this kind of array, or you can say mapping, is there, key value pair. They are recording what was the amount to refund it at the end, because he has bidded into the bidding and he must receive his amount. Someone else has bidded high amount. These are the events. I'm not going to low level detail of this, errors and all those things, but this is the constructor where we have supplied those bid end time and beneficiary. It is stored those things earlier into those state variable, and then this is the bid function which we were using to bid. So we are providing the amount, and using this amount it is checking whether the block timestamp, like when you are trying to bid, whether the bid like auction is already end or not. If it is not ended, then only you go further step, your bid will be accepted or not based on the bid amount. If bid amount is smaller than the highest bid, it will not be accepted. And it will checks, like all those checks will be done. Like these are the conditions. When you are writing a contract, these are the conditions will be there in the contract. So terms and conditions, when we talk about contracts, these are terms and conditions. But this should be precisely written. There should not be any ambiguity. Like in the paper documents, we may have some ambiguity, but when we are writing the contract, it should be precisely written. It should not have any ambiguity in the contract. And this is like how at the end, when you are the highest bidder, it is stored those information into the highest bid and highest bidder state variables. Similarly, this function is withdraw when auction is ended and you are not the highest bidder, you can withdraw your amount using these functions. So several other functions are there, auction end and all those things. So next, when I'm going to talk about parallel execution, I will be talking about these transactions and the input parameters of these transactions. So here we have this transaction, right? This successful transaction. What was the input parameters? And currently these transactions are executing sequentially one after another. So how we can execute more transaction in parallel, because Ethereum and Bitcoin have very low throughput. Like if you talk about Bitcoin, it is 7 transactions per second. If we talk about Ethereum, it is 35 or 30 transactions per second. So throughput is quite less. So how we can improve the throughput, that is the part of this talk. So contract, I think already we have talked about contract, so I am skipping this. But how Ethereum works, let's talk about that. So Ethereum node forms a peer-to-peer network. It's a distributed network. There's no centralized control. Like everyone here in the auditorium is like kind of, you can think of as a node in the Ethereum blockchain. To make any change, there need to be a consensus between everyone. Like if someone want to go outside the auditorium, at least more than 51% have to agree on that. Then only that person can open the door and go outside. So that kind of, you can think of as a blockchain where these are the nodes, and any change must be accepted by the majority of the node. So the clients or the user are the external users who are submitting transactions. So they basically submit the transaction, they are calling the function call. This is smart contract function which we have just in bid. So they submit those requests, and these requests go to the peers they are connected with and kept into a pending transaction queue. So when this transaction is kept into the pending transaction queue, these nodes keep on collecting such transactions, and then they start processing those transactions. So they select transaction, create a block, and then execute those transactions and put into the block. So here in this example, you see here like we have 4 peers, and their state is like the consistent state is up to block B3. Everyone is having B3 state. Peer 4 collected those 3 transactions, given it to everyone else, and also started proposing a block. So when it start proposing a block, what it do is it select transaction, execute those transactions based on its local ledger, and compute a state, final state. So Merkle root and that Dr. Amit was talking about. So it compute the final state, keep it into the block, and compute the hash of the block, or putting the previous block hash and solve the proof of a consensus. So assume like peer 4 was the winner of this process, and it broadcasted that block to everyone else. When everyone else received this block, Based on their local chain, like their local view of the blockchain, they again execute those transactions which they have received in block B4. And based on their execution, they compute the state. They are applying those transactions into their state and they compute the state. And then they compare the state, whatever they have computed, with the state in the block. If they found like the state is same, they accept the block. Because if everyone is in this chain is kind of working as per the protocol, they obviously will get the same state and they accept the block. Otherwise, if someone who is the malicious and proposing a invalid block, they will be caught and the peers will not accept such malicious block and reject that block. So when in the best case, the block will be accepted because the peer was the legitimate peer and proposed the block and everyone accepted that block. So here one important thing is like when everyone is agreed, the block will become part of, not everyone, majority, the consensus is reached, block will become the part of the chain and this block will be accepted. So what's the bottleneck here? Like in the existing blockchain platform like Ethereum, Bitcoin, these transactions are executed one after another. And that's the requirement, like it should be serializable. But having the multi-core system or resources, this transaction are still executed sequentially. And this lead to the poor throughput, like throughput is quite less. That is one of the challenge, like transaction throughput or scalability, you can say. Scalability is the, if we talk about scalability, it is in the broader sense, transaction execution is one of that limitation. There are other limitations like when number of users or transactions are increasing, how system will be able to handle. When number of nodes are increasing, how system will behave. Like whether it is slowing down or when the data is increasing, how to handle that. But transaction throughput is one of the requirements which directly impact the user experience. Because let's say if you have submitted a transaction and you are at a retail store and that store is using blockchain technology and you submitted a transaction to purchase something and that transaction will take 10 minutes or 15 minutes or more time, then you can't wait there, right? You want your transaction to be processed faster. So when number of user or requests are increasing, system have to process more transactions faster way. So the throughput is one challenge there. Other challenges like consensus protocol, communication protocol, and those things are there, but how we can improve the execution of transaction via parallelism. So when two transactions, let's say transaction T1 is transferring some amount to user 1 to user 2, and transaction 2 is transferring to user 3 to user 4, they are completely operating on different data items. They are touching different data. So can we execute those two transactions in parallel rather than waiting or executing them sequentially using the resources available with the system? So this is one example, like the coin transfer example, where we are transferring, the sender is sending some amount to the receiver, and it checks, the function will check like whether the amount, the sender's amount is sufficient or not. If sender amount is not sufficient, the transaction will not succeed. Otherwise, the sender balance will be deducted and receiver will be credited. So here in this example, we have two transactions. T1 is transferring A to B $10, T2 is transferring C to D $20, and these are completely two different transactions operating on different data items. So we can execute them in parallel. So here, the time, if you think going from left to right, it is taking more time for executing these two transactions. But when we execute these two transactions in overlap manner, ensuring that there is no violation of the serializability and this thing, we can process more number of transactions. Yeah. So when we try to execute transaction in parallel, there are many other challenges. Like existing platform, if you talk about Ethereum, it don't have a parallel execution support. Like Ethereum virtual machine is completely single-threaded execution. You can't execute more transaction in parallel. System is designed that way. So to execute transaction in parallel, we need either the Ethereum virtual machine is multi-threaded or the platform which is executing transaction in parallel somehow. So transaction may have conflicting accesses. Again, when two transaction, like double spending is possible. I'm transferring $100 to Dr. Shamsundar and I'm transferring $100 to someone else, and I have a total 100 rupees. So if you're executing those transactions in parallel, it may possible that the double spending is possible. So we have to make sure those conflicting accesses should be executed sequentially. So yeah, non-deterministic parallel execution of transaction may lead to the rejection of a valid block. I will talk about this later on. And the malicious miners problem. So with the concurrent execution, if a miner is malicious, they play with the block and try to achieve the double spending. So we have to be very cautious about those things. So the first challenge is like identifying the conflict at runtime, and because many blockchains don't provide the data the transaction is accessing, like the Ethereum, the solidity is during complete language, and it may have conditions and various control flow when transactions are executed. So we don't know whether the transaction at the like static time, we don't know what state variables or accounts they are touching. So we have to need some mechanism that can detect those conflicts during the execution. If we use the traditional database parallel execution concurrency mechanism like logs and these things, and if we use those logs improperly in Ethereum or any blockchain, that may lead to deadlock and blockchain may become to a halt. So we have to be very cautious. We can't directly use logs there. Discovering an equivalent sequential schedule or serial schedule is important while executing those transactions. So here, if we talk about centralized system and the concurrency mechanism, there is only one server that is taking care of the execution. But when it comes to the blockchain, there are multiple nodes. And when miner or the block proposer is executing transaction, it may execute those transactions parallelly in different order, and then validator may execute in different order. So we have to make sure whatever order that miner have executed, all the validator also follow that order. So and when executing transaction, we have to make sure it should be equivalent to some sequential schedule, or it should be as if we are executing transaction sequentially after one after another. If let's say one validator don't have the parallel execution platforms or multi-threaded system, it must be able to execute those transactions sequentially and should lead to the same state as what the miner have reached to accept a valid block. So one of the concurrency control mechanism, which is known as software transactional memory, that is being used in the others traditional systems, we can use one of such system to identify or to mitigate those challenges which I was just talking about. But the important challenge is like, let's say miner is proposing a block and executing those transactions parallelly and giving it to the validator. So here we have two transactions. T1 is transferring A to B $10, T2 is transferring B to A $20. So it may possible like at the block proposer, transaction T1 is executed such that T1 is followed by T2 in the sequential schedule. So the final state, if you see here, T1 is transferring A to B $10. So after transferring $10, its final state must become 0. And when B is transferring T2 to A $20, so after the transaction 2 is successful, the B's final state should be 0, and those $20 will be transferred to A. So here you can notice AB and BA, so the same account. I'm transferring to you and you are transferring more money to me. So that way here, if the execution order is T1 followed by T2, this is the final state at the block proposer or the miner. When executed by the validator, let's say miner haven't provided any information and validator is executing them, T2 followed by T1. So though the block was the valid block, it may possible T1 is trying to transfer B to A $20 and B don't have sufficient balance into his account. I hope it is visible. Okay. So yeah. So if in this order, if validator execute T2 followed by T1, T2 will be aborted, only transaction T1 will succeed. And though the block proposer was the legitimate block proposer, its block was rejected. And that's the concurrency issue when transactions are executed parallelly to increase the throughput. So what can be the solution? So one solution can be like block proposer when executing this transaction. For conflicting transaction, it records the information into form of a block graph or a graph. So here, the block proposer executed transaction T1 and then T2. So it records that information into the block and give this entire block with the final state to the validator. When validator receives this block, it knows like a miner have executed T1 followed by T2, so it respects that order and execute transaction in that order, so that it also reaches to the same state here. But this leads to another problem, which is kind of like this block proposer can be a malicious block proposer, and it wants to achieve double spending for some benefit. So what it do is it do not provide this dependency information and propose this block. So again, the same thing like when two transactions, this T1 and T2 executed parallelly, it may possible the same account will be detected 2 times. Though here the example is slightly different. Here we have A1 is transferring A to B $10, T2 is transferring A to C $5. So A have only 10 rupees and it tried to spend 15 rupees. Because of concurrency, it may possible it is able to transfer those 15 rupees. So to mitigate this issue, like the validator when executing, it need to identify there were supposed to be one dependency which was not provided by the miner, and because of that I am executing those transactions in parallel. So it have to identify those cases and reject such malicious block proposed by the malicious miner. So yeah, there are different approaches. One of the approach is like statistical analysis based parallel execution. So this technique require all the access information, like what are the account a transaction is going to access. This is practically implemented now in Solana blockchain and even Hyperledger Savtooth. And there are a couple of more blockchains which employ this technique there to execute transaction in parallel. So what this technique basically do is it select all those transactions, their access information, like what are the account they are accessing, and then schedule those transactions which are independent into parallel, and those transactions which are dependent sequentially one after another. One of the approach which we have proposed is like using those transactions and analyzing those transactions to prepare a schedule. We follow a leader-follower approach where leader prepare those schedule for the execution. This is a kind of distributed community. What we have done is, like, let's say we have a single node in the blockchain network and it have more power to execute the transaction. So we use that distributed compute power of the system. So if you think like when a blockchain network is growing and there are more number of transactions that are coming to the individual node, they can employ their cluster mechanism to process those transactions and to do different tasks like broadcasting and those different blockchain tasks. Yeah. So the leader group that block transaction into independent shards or different independent groups of transactions, like all the transactions which are dependent on each other accessing the same account will be kept into one shard or one group. Similarly, those transactions which is dependent on another account, they are accessing another set of accounts, they will be kept into another group, and these two groups will be executed in parallel. So this is transaction execution sharding, and this is not key value sharding or the blockchain node sharding. It is transaction execution sharding where different transactions are grouped into different sets and then executed in parallel. So here is one example of that. I hope it is visible. So we have 9 transactions and their access information is available. So by using those access information, we generated 3 shards. Shard 1 is having A1, A3, A1, A8, and A2, A3. So here, if you notice, they are accessing at least one common account in between all those transactions. Similarly, there is shard 2 and shard 3. When these shards are given to the followers, you can think of a different compute machine which is executing those transactions sequentially one after another. But all these shards are executed in parallel. So when a community is acting as a miner, there will be transaction in the pending transaction queue. The leader, one of the node in the cluster, set of cluster, one of them will be leader. It select the pending transaction. It perform the statistical analysis and create different groups and give it to the different followers. It may possible like we have more number of shards than the follower. So the leader will load balance those so that we will perfectly load balance, and every follower will be almost executing the same workload and the execution will be faster. So here if you think like there are 100 transactions, and if those 100 transactions executed one after another, it may be like, for example, it's taking 100 seconds. And let's say we shard those transactions into 10 different shards, and all those 10 shards are executed one after parallelly, but internally sequentially. So those 10 will be executed parallelly, so 10 seconds, somewhat, 10 or 15 seconds. So we reduce 100 seconds to just 10 seconds. So more transactions we are able to process in parallel. So when miner acting as a mining community internally, it execute those transactions, compute the state, and then propose that block to the validator community. So here, those transactions will have their order, the sequential order, which the miner will propose based on this shard by shard. Internally, those shards are executed one after another. So if a validator community don't have multi-core resources or cluster resources, they can simply execute them sequentially one after another and reach to the same state. This is the case like when a validator community, when they receive such a block, again they will have a leader, and the leader will again perform the sharding. Here we are not providing any information to the block because the statistical analysis always lead to the same shards. Because they also have the transaction, they can perform the statistical analysis and they get the same shards, same number of shards, and execute them in parallel. So the thing is, though they are executing in parallel, within each shard, those transactions are executed sequentially one after another. So it may possible like those transactions further can be executed parallelly. Like for the example, we were taking 10 transactions, one after another, 10 seconds. So can we execute those transactions further in parallel without losing any leading to any issue? So that's where like the runtime technique come into picture, where we will use the multi-core resources available within the single machine to run the transaction in parallel through, and at the runtime they detect if there is any conflict, and if conflict is there, they resolve the conflict based on the transaction order and then execute them in parallel. If two transactions T1 and T2 are dependent, they will ensure they will be executed T1 followed by T2. But it may possible those two transactions are accessing more number of data items. So the data item they are not conflicting with can be executed in parallel, and those will be recorded into their state. So STM I was talking about, like what is software transactional memory system. It is concurrency mechanism where the programmer need not to worry about low level details like date logs or priority inversion or many things which may be there if we execute the transaction in parallel using traditional log-based systems. So it exposes some API, like it gives you some functions, you use those functions and write your program such that it can be executed in parallel, and you need not to worry about the background processing. It will make sure your transaction will be executed parallelly without violating any consistency thing. Yeah. So by employing the STM system, we can execute more number of transactions in parallel. Yeah. So the OptiSmart approach is that so this approach involves more things, like in a block there may be many transactions. Some of those transactions may not be dependent on any other transactions. So identifying those transactions and keeping them in, they can be executed in any order because they are not conflicting and they will lead to the same state, but there may be transactions which are dependent. So for dependent transaction, it records the information to the form of the graph that we were talking about, and then that block will be given to the validator. Like you have a concurrent transaction, set of transactions that can be executed in any order, and there is a set of transactions that must be follow that graph order. So when this block is given to the validator, they will use that information to execute transaction in parallel. So STMs are like convenient programming paradigm for programmers to write the concurrent program. Here are some of the functions I was talking about, like STM begin, STM read, STM write, STM try commit, and STM abort. So these are the functions that will be used by the programmers to write the concurrent program. And there can be different protocol in the STM itself, like a basic timestamp ordering protocol or multi-version timestamp ordering protocol. I'm not going into much detail of those, but these are the protocol which is used to execute the transaction in parallel. So in the beginning, when a miner start proposing a block, is select all the transaction, keep them in a concurrent bin, or like there's a bin where it put all the transaction and start executing those transactions. At the time, if it identifies that two transactions are conflicting, it remove those transactions from the concurrent bin and add into the block graph. Like these two transactions are conflicting, they should be executed in this order. I'm executing them T1 followed by T2 or so. So at the end, when this execution ends at the miner, it will have a set of transaction which is in the concurrent bin, set of transaction in the block graph, and the state after the execution. It put all those information into the block. There are more information like how the conflicts are identified in the read-write STM or multi-version read-write STM that may be very difficult to understand at this point for the audience, so I'm skipping this thing. But you can think of, there are transactions which can be executed in parallel. There are set of transactions that should be executed in sequential order in the graph. So this information will be given to the validator. Here is one example where we have three transactions, T0, T3, and T7. So this shows how these conflicts are recorded. So if you notice here, transaction T3 and T7 are operating on the same account A. T3 is writing to that account and T7 is reading. So if T7 executed before T3, it will read different value. And if it execute after T3, it will read different value which is written by the T3. So this thing should be recorded into the block, because if this transaction is given to the validator and if he execute T7 before T3, it is getting different value and it may reject such a valid block. So all those information should be recorded into the block, and this shows like how those information is recorded at the time of execution at the miner. So let's assume that block is given. Here we have 9 transactions or something. So this is the concurrent bin which is consisting all those transactions, and this is the graph which is recording those transaction dependencies. So at the validator, it will be two-phase execution. All the nodes have their validator, multi-threaded validator. They first execute concurrent bin concurrently, like all this transaction. 6 transactions will be executed parallelly. Then they execute through the block graph. So one of the thread or the process will claim the transaction in the graph and execute it. So here, transaction 1, transaction 2, and transaction 6 are conflicting, and T2 and T6 is dependent on T1. When T1 executed, T2 and T6 can be executed in parallel. So after the execution of T1, T2 and T6 can be executed in parallel. So if there is one way, like all these transactions are executed sequentially, this is another way to execute those transactions in parallel and to accept more transactions, process more transactions in parallel. So when we talk about smart contract, this there can be value transfer, and which is simply currency transfer. These are micro transactions and small transactions which take less time. But in supply chain or some complex use cases, this transaction may be a larger logic which is taking time in seconds or something for processing. So there, if such transactions are there in the block, it is taking more time. And if we are processing those transactions in parallel, we can process more transactions efficiently through the parallel execution approaches. So yeah, there are a couple of related work there already. So the Dickerson et al. Was the first person who proposed this idea using Scala STM, and there were other solutions, and we have proposed the solution after them. And after this, there were a lot of innovation in the blockchain, like Aptos blockchain. They have proposed block STM-based approach, which is STM-based approach basically, and they were able to process 160K transactions per second in their experiments. So in Ethereum, it is 35 transactions, and they are processing 160K transactions per second, like huge change. And that's what required, like if we talk about Visa or other existing credit card system, this transaction processing, they are processing thousands of transactions, like 30 or 40 transactions per second. So if Ethereum or any blockchain want to be able to process that many transactions and to become a to be a everyday use case of everyone started using blockchain technology, there will be a lot of transactions, and to process those transactions, system should be able to handle and process those transactions faster. Otherwise, transaction will keep on waiting in pending queue, and at the end it will be rejected. So these parallelization approaches are kind of helping there to make the technology versatile to be accepted in real-time cases. These are the guidelines may be helpful for the programmer, but not for the audience, when they are thinking of implementing these techniques into the blockchain platform. So I'm skipping this. So I'm open to any questions if you have, in general also, and on the talk also. Yeah. You are not audible. Yeah, he's coming. Yeah.
Hi, can you revisit that simple auction contract?
Yes. Yeah.
So this essentially is a program to conduct an auction?
Yeah, it is a program to conduct a very simple auction contract. Like you have a commodity and you want it to be auctioned. Like there are multiple bidders in the auditorium. They are bidding for that particular item. Let's say I want to sell my system. So I put this system information in the blockchain platform, and that is recorded into the contract. And there will be a bidder which is putting their bid on getting this particular product. Yeah. Each? All bids. All increasing bid.
When we talk of an auction, it is usually done on a centralized system, each bidder getting the same opportunity. There is no sequential bidding happening. Anyone who makes a higher bid, anyone randomly can come and bid, right?
Yeah, that is one case.
So it is getting registered one over the other.
Yeah, that is one case. The case you are explaining is there are multiple bidders. They are putting their bids. and the auction is telling them this is the highest bidder, okay? So here you don't have transparency, right? You don't know whether you was the actually the right bidder, right? And you won. You don't have the information about other bidders. But when you go to the blockchain, right? So when you are putting your bids, that information is recorded. So I understand like the privacy is one concern, and that can be handled through the other implementing those perspective there, like your bid will not be revealed until the point it is bid is ended, like the auction is ended. So those things can be done. This is just one use case, like showing like how this bid is done. So like all the bids, if it is going through the blockchain platform, that will be recorded as a transaction for sure.
It would be compiled on different nodes, wouldn't it? In case it's going to a blockchain.
Can you come again?
Would the auction be running on a single system, single particular
No,
node,
no, no,
or
no,
would
no,
it be
no,
decentralized running on multiple nodes?
So it is executed in blockchain platform. This is not on centralized system. So this contract is deployed into the blockchain, right? So when there is a bid is coming, a user is initiating a transaction, I want to bid this much amount, right? So that is one transaction. This transaction will be given to all the nodes in the network. When a block is proposed, this block will be given to everyone else to validate. So they verify the transaction, like this user has initiated transaction and this is the bid amount from that user.
Has it been done anywhere?
Yeah, it is done. Right?
Okay. It's just a use case, or it's been implemented?
This is one use case. This can practically be deployed, right? This can be done by writing a contract. Non-fungible tokens, yeah. Yeah.
So the NFTs which you have heard, all the CryptoPunks and CyberKitties and all of those are the same bid contract, much more complex. But that is what is happening there, right?
By the way, this is very simple example, just to give you an intuition about like how this auction is done. It can be written as a very complex example as well. Yeah.
Yeah.
So non-fungible tokens, like let's say an artist have its art and it put it into the blockchain for the auction, that can be done, right? So there this kind of auction is done.
Yeah.
Please.
Thank you. When you say the others will validate each of those bids, who are these validators?
So you have a blockchain platform, right? One of the node is proposing a block, right? It receives the transaction, it proposes a block.
Yeah.
So everyone else, apart from that node, the block proposer, is the validator. They validate the transaction, the block proposed by the miner.
So if it's a competitive environment and there are 10 bidders, what if some of the bidders do not validate the bids made by others? What happens?
So bidder need not to validate the other's bid, right? It is the platform where the node. So you can think like you are a user, okay? So bidders are user.
Yeah.
And then there is a blockchain platform run by, let's say, 10 different organization part of that platform. Let's say finance organization is there, banking sector is there. All those are part of the blockchain platform, okay?
Right.
So when user submitting those transactions, these participants of the blockchain participant, they are validating. And the user, bidders are submitting their request. So you have this contract deployed there. This is the application, right? Here you can see the platform, the user interface I have shown here, where they are putting their bid.
Right.
So you have that part where you can bid. You are using your application, you are bidding. So in the background, there is a transaction initiated. That transaction will be go to the one of the node, blockchain node. So that node will give it to everyone else in the network, and one of them will be proposing a block. So when they propose a block, everyone else, like if there are 10 nodes, okay, so one of them is proposing, other 9 will validate it. So when a majority agrees on that, okay, this is a right transaction, and a bidder put this bid, and he is actually the winner, everyone will agree on that. Okay, right bid, so this is the winner of the auction.
Okay, and just, yeah. Okay. Okay, so could you have a blockchain without a validator? Okay, at least one validator.
Transparency. Yeah. 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 Yeah, okay.
See, validation is done during the auction process or after the auction is done. Because anybody who gives a bid, his name is not proposed in an auction. Only the price, who has proposed, what is the latest price. So
Can you
one
come
has
again?
to-
Can you come again?
No, one has to validate other one's auction price, whether it's a valid bid or not.
Yes.
But that shows that this person has bid what amount it is. That is a confidential thing. Until unless the whole auction process is completed, who is bidding is not known.
Yeah.
At the end of the auction process, who wins it, that needs to be known.
Yeah, so that is, I understood that is one of the use case, there is no privacy in this particular example. I didn't put any privacy because here there are other functions where the person, the bidder can know what is the highest bid at this point in time. Okay, so this is very simple use case, but the privacy concern, like there are different bidders and they don't want to reveal their identity till the end of the auction. This can be encoded into the contract itself and the contract will be written that way, like the other person will not be able to know who was the previous bidder, what was his bid. So that thing need to be written into the code. But this is a very simple use case where these functions are provided itself, like you can know who is the beneficiary at this point in time. So I just simply use one use case to give you an intuition, like this is how a contract looks like and how it records the conditions and what is the function of those terms and conditions. So you have your terms and condition in record and then deploy the contract and interact with that contract. So when auction end, you know who is the beneficiary, who is the winner, and then at that time it can reveal who was the all the beneficiary details also, if you wish to know. Yeah.
So, correct. No,
Yeah.
you just
Agree.
no. Just take this as a use case to just explain what a smart contract is. But you need to understand there are two things you're validating right now. One, you're validating, which is a business logic. Who the validator is the validating amount higher than the previous bidder and all of those. That's a business logic, right? And then there is a blockchain-based consensus which is happening to understand that there is no double spend, there is privacy, all of those which are taken care of. So the blockchain-based consensus which is happening is at a platform layer, which is happening by a validator and notary and all of those which are technical. And the business level validation is happening based on the smart contract which is written as certain set of if and then conditions. So take them as two different layers for you to worry about. And think of this as just an example. Don't go into the schematics of why is this happening. This was just one of those.
Come again? Right now I don't have, but I can share with you. I will find out and will share it with you. Yeah.
Sir, one question for you. You mentioned that validity of the bidder, whether once a person is bidding, whether the bidder is, whether his bid is valid or not, that will be done at the blockchain level itself.
Yes.
Means whether the bidder is genuine. Suppose, for example, a bid is thrown and the value of the, means the one person has bidded, say, $1 million USD, and there is another bidder who may not be capable of $1 million USD, and if he is bidding, say, 110 million USD, then is that bid valid or not? Will it be verified by the blockchain itself?
So if you had oracles available which could check his credit scores, or if he could check his bank account details, could have been done and said that before you bid or when you bid, we will do that check, and then that is when we will authenticate and say this bid is valid or not. So those could be written on the code. Right now what he is showing is a very simple example of your smart contract. Just to show you, because from morning we are talking about so many smart contracts, no one has really seen a smart contract. We thought we'll show you a green screen with some geeky code on it so that you guys can understand it. Yeah.
Just want to ask one thing.
Yeah,
How do you
thank you.
encapsulate subjective conditions in a smart contract? Subjective clauses.
it depends, right? How you are encoding them, right? So another thing like is he was talking about like oracles, right? Any external things which want to be like, so blockchain completely runs in isolation. They not have anything that they can interact with external world, right? So there is a requirement of oracles that provide that information to the blockchain network. Like this is a legitimate information, you process it. So when it goes to the blockchain, they can process, they can understand, okay, this was the correct input provided by the oracles and we can trust it. Otherwise, the system completely run in isolation. They will not be able to interact with the external world. There's a requirement of input oracles, there's a requirement of output oracles, which take the information from the blockchain network and give the external world. So there is an oracle interface is required there.
No, so in cases of disputes, so
Yeah.
if this contract or this bid leads to a dispute, now would a adjudicating court require your oracles, the smart contract, as well as the, the clauses, subjective clauses? So how will it get to know what all has transpired?
So code is the law, right? Whatever recorded into the contract, it can't be changed. So the blockchain will be able to process only that information. Any dispute outside the blockchain need to be solved externally only. And if the contract is not able to handle those things and you want to change the contract, that require the deployment of the new contract based on the agreement between all the parties.
I think that was a great example. If it's a lot of life in the audiences come up. Like what sir was saying in the morning, garbage in, garbage out. So that's what it is. The code is, that is what it is, right? Garbage in, garbage out. The second thing is, the smart contracts are very deterministic. You can't have a subjective thing. So if 2 plus 2 is 4, 2 plus 2 is 4. And you need to have an end. It can't ever be in a loop or in an undecisive state. If you can't get an answer which is in the deterministic, then you can't write a smart contract. Then you need to do what sir was saying, that you need to have an oracle which is a human oracle. If that is the case, then you bring a human intelligence in it to do it.
No, I think in my impression, his intention was to show how you can scale up the smart, I won't say smart contract, the blockchain platform. Okay, smart contract cannot be scaled up because this is a small thing which happens or the other. So I think, for example, in auction, suppose you want to say anyone can bid, the highest bidder would be chosen. Naturally, none of the bidders should be known to the others, and it cannot come on the, if it comes on the blockchain, it's a problem. In fact, this is something I think people have to understand. In a classic blockchain, everything is public, so this will not work. You have to go for privacy preserving transactions like zero coin or something like that. Otherwise, it will not work. In fact, some of the games, what the exploitation shows is, if I know what is the, like if I play a 1-2 game or 0-1 game, if I know that this is the person he has put 1, because it's already there, I know I will not put that. So that will not work, and that is some of the things what you have to understand. Because it is public, there are some things what you thought it was secret, it is no longer secret. You have to make it a private variable so that it will not be seen to the outside. So these are some things. He showed it, in my opinion. That's why I asked him, you tell what is the problem this solves, because nobody will go through that code or the other. So if a simple auction where you have to choose the highest bidder, naturally all the bidders who have bid have to be secretly given the name, and it has to be opened only at the strike of time T1. And now synchronization of time also is a problem in auction, because if somebody just now say it is just like Krishna putting this one, it is not at sunset kind of a thing, it becomes a problem. So these are all things that technologically what can be handled in this smart contract. Like what you said, what would be the dispute? There will be no dispute as far as smart contract is concerned. It's only on the performance, and if you say whether he performed well or not, it does not know. He just performed. So that's all the thing what it is.
Thank you so much, Professor.
Excuse me?
No, for all the practical enterprise requirements, you have to adapt it to many of the requirements. Now you have non-fungible tokens, etc. This, one of the natural protocol on Ethereum was ERC20, what I mentioned. If you use it straight, that one, you will end up in a problem. And lots of money have been pilfered because of that flaw. But you have to see, that is how I said, you have to do a very careful coding. Smart contract is hard, and now you have to say what is law and what is code. You see, what is the difference between privacy and security? Anyone? Or is it privacy security? No, privacy is you can give up your information with your permission. But privacy can be implemented using security measures. But it is not private. For example, your name is not a secret. It is public. It is not even public. It is private. That's how you put a badge to say I am so and so. So there is a difference of the other in a privacy kind of a thing. That's how if I want to do confidentiality, either you have to go privacy preserving blockchain like zero coin, zero cash, and so on and so forth. Like that.
Thank you so much, Professor, and both of you for
yes, sir. One more question. In a forward auction, it once so happened that all the bidders were sitting in a hotel room, and they made a cartel, and they were bidding, and they somehow it was known. Can that type of fraud be detected here?
No.
It cannot be detected because same, maybe different IP addresses. Huh? No, not same point. Same server, then the IP address, it is natural. That can be known. Okay, okay. Right, sir. Thank you.
Yeah. Thank you so much.
I want.
Yeah. So pipelined execution of the smart contract, right? So it's like how, in what context you are saying this? Like within a blockchain execution platform, when these contract transactions are executed, so you are executing them in pipeline way, you can, if they are not having any conflict, right? If they are having conflict, the pipeline will break.
Yes, sir. I am asking about the efficiency of the smart contract execution in parallel and pipelining execution of smart contract.
So I haven't done any experiment on pipelining execution, but yeah, that is kind of one thing. But it's again challenging, right? Yeah, it's sequence. Where sequence breaks.
Yes, sir.
Yeah.
Time. Yes, sir. Yes. Yes, sir. Yes, sir.
Performance.
Yes, sir. Yes, sir. Thank you, sir.
Yeah.
Thank you very much.
Yeah, thank you so much. Yeah, yeah, that's all.
That is called being dot on time because you're almost touching 4. Thanks a lot. We will break for the day, and tomorrow we are meeting at 10 as far as the session starts. And those who are interested in a bit of Pet Puja, they can come a little earlier. Okay.
Thank you so much.
Thank you. Thanks a lot.
Requesting Madhuran Kumar to hand over the memento to Dr. Parvat Singh Anjana. Thank you all.